potential barrier height of hole and electron. Similarly, the intra-ball tunneling on the hole performance increase. So due to these reason, the overall optoelectronic performance of deep ultraviolet LED increase. There are some future perspective from this work. This innovative structure can be used for experimental study because our study is based on simulation. The second one, these approaches can be extended for the other optoelectronic devices, especially for laser. And the physics explained behind this problem of ultraviolet LEDs may provide a new direction to other optoelectronics devices. Acknowledge. I am deeply thankful to my supervisor, Professor Habibullah Jamal, and co-supervisor, Engineer Dr. Muhammad Usman, for its continuous guidance and motivations. I am also deeply thankful to the NED University of Engineering Sciences and Technology for arranging this valuable conference, and I am also deeply thankful to the first International Conference Applied Physics and Engineering Organizing Committee to provide me opportunity to present my work. I am also thankful to the GIK Institute and my all family and graduate colleagues. Thank you so much for your attention. Thanks.
As the author is not available online to answer any queries, so I think we can proceed further.
Yes.
For the next.
If anyone in the audience have any query, you can email us on the conference ID.
Thank you, Mr. Tariq Jameel, for your presence. It is a pleasure to invite our next speaker, Mr. Asad Aslam from Sir Syed University, to elaborate his work on quantization era in time to digital converters. He will be also joining us through recorded video. Please give him a warm welcome.
Yeah, hi, this is Asad Aslam. I am going to review about quantization error in time to digital converters. So let's start from abstract. So as you all know that methods of time interval measurement can be divided into asynchronous and synchronous approaches. So when dispersions of result caused by noise is present, a mathematical model of averaging, which is followed by the results of numerical simulations of averaging of measurement series is presented. So now I am transferring mic to my colleague, Mr. Mohammad Zishan. So he will give you a more introduction about our research work.
Thank you, Asad. Hi, this is Ishan. I'm gonna briefly describe you that how quantization error occurs in a time to digital conversion. The resolution of a time to digital converter is still increasing, often is better. The quantization error can be decreased by averaging a series of asynchronous time interval measurements. Quantization error can be reduced by averaging techniques. If the quantization error is zero, the uncertainty of measurement depends only on the standard deviation of measurements. For the summary, I will now call Muhammad Yasir Razak to please describe what the conclusion is.
Assalamu alaikum. How are you? Thanks, Mohammad Zishan, to give me the chance to express some word regarding to our research paper. As you know that the analysis of the result leads to the conclusion that is a particular condition, the influence of the quantization error and measurement uncertainty can be minimized by statistical averaging. Similar to our asynchronous measurements, the aim of this article was to discuss the averaging of the result of time interval measurements. We can say that the mathematical model of averaging for both synchronous and asynchronous measurement is presented. The result of the simulation for asynchronous measurement correspond to the theoretical approaches. And the presented result of the studies can be applied in error analysis of the synchronous measurements. For asynchronous measurement correspond to the theoretical approaches. and the presented result of the studies can be applied in error analysis of the synchronous measurement system. Hope you liked our research. Thank you. Have a good day. Thank you so much for giving us time.
I think so. Yes. Thank you so much, Mr. Asad Aslam. The session is open for question and answers. Any questions from audience? No?
Mr.
Okay.
Asad Aslam is not available right now.
Oh, he's not on English. Okay. Now we move forward to our next presenter, Dr. Hassan Wasim from Sir Syed University of Engineering and Technology, to talk about his paper entitled A Survey on Wireless Sensor Network and Cryptography. The co-authors are Anas Khan, Syed Ahmed. Ladies and gentlemen, please welcome Dr. Hassan Wasim.
Assalamu alaikum wa rahmatullahi wa barakatuh. Greeting to all. I hope you all are doing well. We are the students of Sir Syed University of Engineering and Technology from Electronic Engineering Department, 2018 batch. We had a survey on wireless sensor network and cryptography. Now, I would like to introduce myself. My name is Mohammad Anas Khan, and my colleague is Hassan Wasim. Now, moving to our topic, what is wireless sensor network? Wireless sensor network is a network made up of a distributed sensor nodes that collects data from the environment and transmit it along the network. Since it is a wireless network that sometimes is even used in a hostile environment, protection of the data is essential as it's vulnerable to multiple typical type of security threats. How it works. Wireless sensor network have become more and more common in several programs that are spread over a wide spectrum of fields which collect environmental data. Its applications are useful in numerous fields of science and technology, ranging from the monitoring to surveillance, automation, monitoring physical phenomena like ocean, wildlife, wildfire, disaster relief operations, mapping, agriculture precision, military, medicine building, safety, etc. As they are progressively becoming part of IoTs, the safety of the information they collect is becoming more and more critical with ad hoc surroundings, giving a hard time to security and safeguard of the data. Now moving towards structure of wireless sensor network. Wireless sensor network are made up of small devices known as nodes. Each node is a tiny computer with an embedded CPU, some computational power, and a smart sensor to sense the data. These nodes communicate and cooperatively with each other using wireless connections. Communication is crucial between the nodes to make centralized network. There are namely two types of nodes in the wireless sensor network, namely sensor nodes and gateway node. The architecture of wireless sensor network consists of sensor nodes and gateway nodes and a user or an observer. How it works. Each node is a network has a different goal. In the area that we need to collect the data, nodes are placed in different places to form network in such a way that they coordinate with each other to communicate and share the data. Sensor nodes are placed according to certain topologies like linear star mesh. Node topology is in node placed in any topology have a limited broadcast range, typically 30 meters. Now moving to our next slide, technology in wireless sensor network. Wireless sensor network is a collection of made multiple sensor nodes and a gateway to transfer the information through the internet. Now the main thing is sensor node. Sensor node are one of the main part of wireless sensor network. This type of node is a small, low-powered piece of equipment. It is a low of cost and has a synchronized processing quality. It collects or senses the data from the surroundings and transfer to gateway. Now, sensor transducer. The most important part of wireless sensor network are the sensors since they perform the most crucial task of sensing the data from the surroundings. The transducers convert the environmental data like heat, temperature, smoke, sound, light, density, pressure, humidity, etc. into an electrical signal. There are different type of sensors according to the data that collects like chemical sensors, smoke sensors, pressure sensors, ultrasound transducers, piezo sensors, biosensors, which are collectively MEMS and microelectric mechanical system. Now, moving toward transceiver. A transceiver is a part of wireless sensor network that is used for wireless communication. Four basic states of a transceiver are receiver, transmit, rest, and sleep. Since it is a wireless communication, radio frequency and laser and infrared are chosen, but the most preferable and widely used one in radio frequency because of its operational range. Now moving towards our next point, power source. To perform the action such as sensing the data from the surrounding, computing the data, then transfer the data takes energy. Placed at the base of the sensor nodes, the power source provides power to different components of sensor nodes like the sensors, CPU, and the communicating unit. Power sources such as batteries, solar cells, etc. can be used to power the sensor nodes since they are very small in size. Now moving to microcontroller, it is the CPU or the brain of a sensor. It is located to the base and work together with the sensors and the radio. It is composed of microprocessor and a flash memory and it performs important functions such as making decisions and dealing with the data that has been collected. The CPU stores the data in the flash memory until data is collected for the transmission. Once enough data is collected, the microprocessor part of the CPU packs the collected data into envelope. The envelope of collected data is sent to the radio of transmission. The CPU also communicates with each other nodes to maintain the make most efficient network structure. Now moving to our last point of technology, operating system. Each CPU needs an operating system to work. Tiny OS meant is patent and Contiki system. Each CPU needs an operating system to work. Tiny OS, Mantis, patent, and Contiki are commonly used. Tiny OS is the operating system that is open source and conserves energy. Now moving towards security requirements in wireless sensor network. It is vital to choose the best security method to protect the data sensed and collected by wireless sensor network. The most important security requirement in wireless sensor network is confidentiality. Protecting privacy and restrictions on information access and making sure that no one reads the message except the intended recipient and since nodes sometimes deals with sensitive information
Thank you so much.
Network integrity is comprised due to a lot of reasons. These a presence of malicious node is the network inject. For example, a presence of malicious node in the network can inject the wrong information, or sometimes due to the unstable condition of the wireless network, some data could be lost. These were the most important security goals that should be available in every system. The secondary goal, however, includes self-organization and time synchronization and secure localization. Now, moving to self-organization. Every sensor node in this wireless sensor network need to be self-sufficient and adaptable and flexible enough to be self-healing and self-organizing according to different situations. Now, time synchronization. Many wireless sensor networks applications depend on the time synchronization. It is helpful in conserving energy, and it helps the node to go into sleeping mode when inactive. All the nodes in the network have a common time reference. Secure localization. One of the advantages of a sensor network it is its ability to perfectly pinpoint each sensor presence in the network automatically. This helps in figuring out a fault in the sensor network, since it would need accurate location of the weakness in the system. Now it's the end of our first topic. Now moving to our next topic, which is cryptography. Cryptography is the way of protecting information by changing the plain text into a meaningless form. It performs a big part in science of secret writing. Cryptography provides number of security goals to ensure privacy of data, confidentiality, authentication, integrity. The basic idea of cryptography is to encrypt the plain text into an incoherent form that is not understandable by anyone who doesn't have the decryption key to ensure the security of sensitive data. Many cryptographic techniques have been proposed to secure the wireless sensor networks, such as asymmetric and symmetric cryptography. Which is symmetric cryptography? Now, I am explaining it. Symmetric cryptography, also known as secret key cryptography, uses one similar key for both encryption and decryption. Example includes data encryption standard, triple data encryption standard, DES, 3D, triple DS, etc. And asymmetric cryptography, which is also known as public key cryptography, uses two different keys, one for encryption and another for decryption. Okay. Now moves to blowfish, which is what is blowfish? Blowfish algorithm. It's basically an algorithm. The blowfish algorithm was introduced in December 1993. It was most effective algorithm in all symmetric key algorithms. It uses now moving to DES. What is DES? Data encryption standard. Data encryption standard was introduced in 1977. It is a symmetric key block cipher, since it uses the same key for encryption and decryption. DES, data encryption standard, use or accepts 64-bit long plain text but only use 56-bit, and discarding the remaining 8 bits. It means that DES use 8 bits as a parity bit and also show result in 64-bit. Same key used for data encryption and decryption with slight differences. Data encryption standard is not safe algorithm because in 1998 this algorithm was cracked by using Electronic Freedom Foundation constructed device within 22 hours. The function is based on the 4 stages such as expansion, key mixing, substitution, and permutation. Okay. Uh, Now moving to our next point, triple data encryption standard 3DES. Triple data encryption was developed in 1978. 3DES means to apply DES algorithm to the data block 3 times each encryption and decryption encryption. 3DES is a symmetric key algorithm, means that the same key is used for encryption or decryption of information. 3DES has a block size of 64-bit and 3DES use 3 keys. Its variable length key is 128 or 192 bits. It consists of 48 ROMs. In 3DES encryption algorithm, first the plain text is encrypted by using first DES key, then the first output from first step is decrypted by using second DES key, and then second output from second step in decryption using third DES key. The output of the third step produces the 64 cipher text. Now it's moving to our next slide, which is conclusion. Since the need of wireless sensor network is increasing in the recent year, the data it computes and transmits need to be protected. In the absence of proper security, the network is susceptible to many threats. Through crypto algorithm, we can save our data from unauthorized users. In this paper, we talked about security requirements, the threats, the technology of wireless sensor network 2, and the cryptography algorithm which we use in wireless sensor network. Before we apply any algorithm to wireless sensor network, we check the algorithm speed, security, complexity, and key length. The number of bits increase, the time to encrypt data also increases. In this paper, we compared symmetric algorithm, asymmetric algorithm named as Bluefish, AES, DES, triple DES, etc. Now it's end of our presentation, and thanks to all.
Thank you so much, Mr. Hassan Wasim, for your insightful delivery of your work. Since he's also not live with us, so any questions from the audience is requested to be emailed on the conference ID.
Before moving forward, we would like to play a pre-conference workshop and sponsor video. Please play for us.
Now, moving forward, I consider it great honor to invite our next speaker. He's from Kenyatta University, Kanye. His contribution is on optimization of air conditioning control to enable energy saving. The co-members of the work are Nayang Raifu and Manji Matthew. He'll also be joining us through a recorded session. Please give warm welcome to Mr. Kavita Denis.
Air conditioning control to enable energy saving. My name is Kavita Dennis, and my supervisors are Dr. Nyange and Dr. Munji of Kenyatta University. Now, these will be my presentation outline. Space cooling demands are increasing steadily throughout the world, whereby the developing history of ACs can be related to efficiency, technology, human comfort, and energy consumption. Technology is playing a key role in digitization of these systems, whereby sensors and microcontrollers are being used intensively to enhance the control of the ACs. Now, the main challenge that I need to solve here is energy conservation, whereby I'm looking at integration of different sensors which can work independently in terms of for example, in terms of entry and occupancy, to be able to reduce the running time of the ACs and therefore reducing the costs in terms of the power usage. The general objective of my research is to design, fabricate, and test an energy-efficient smart air conditioning system based on passive infrared sensor, temperature sensor, proximity sensors, and Raspberry Pi 3 microcontroller. The specific objectives are to design and fabricate a smart air conditioner, to detect a person when approaching a building, to monitor the presence of a person inside a room, to detect the temperature inside that room and feed the information to the microcontroller, and again, obtain the information on the working of the system online through a mobile app. This study is justified by the fact that people are striving to have a higher quality and more comfortable modern lifestyle, and therefore they are looking for machines that are reliable. Intelligent systems remain the main focus of scientists and engineers, whereby modifications are being done on existing systems to increase their efficiency. Two assumptions have been made in this research. One, only humans are in the environment, and again, there is no conflict of interest. Several researches related to my work have been done. Armstrong et al. In 2013 designed an intelligent system, and his recommendation was on multi-input and multi-control systems, which is an area considered in this research. Cheng and Lee in 2014 also conducted a study similar to that. He was using smartphones, devices, and majorly he was emphasizing on wireless devices. As much as wireless devices have a promising potential, battery lifetime remains their main challenge, because they have to be in sleep mode for some time before the signals are received, and that reduces the effectiveness. And we know that energy consumption and efficiency are inversely proportional, according to Riches in 1989. Ozkan et al. In 2016 also made a smart home automation system whereby you could be able to control that system using internet. So his research was, rather his system was entirely controlled via internet, and therefore that was another limitation. Liang et al. In 2018 made an energy saving controller which could be able to switch on and off lights in a building as well as an AC. However, his system was not flexible to temperature and majorly emphasized on the levels of humidity. Mehimet and Eriti in 2018 conducted a study similar to what Cheng and Lee did on smartphones, and he could be able to switch on an AC system and monitor, and therefore he could still be able to monitor different rooms independently. The main challenge he was facing based on his recommendation was energy conservation, an area considered in this research. Nabil in 2019 also conducted a similar to what Cheng and Lee did by use of wireless devices, and therefore this a challenge similar to what Cheng and Lee faced was faced here. Then in case inside the building he was using a PRS sensor, and that made that in case somebody forget that system on, there was no means of switching it off. Eram and Samudra in 2020 conducted a study similar to what Merimet and Eritin in 2018 did, and the main challenge again they were facing was energy conservation. So the research gap that we are looking at here is in terms of energy consumption, and again we are looking at how can we be able to conserve energy, given that people in a particular environment have different behavior due to culture, upbringing, education background, and that makes their influence on energy consumption actually variable. The materials that I've used in this research is a TIR38 PRS sensor, a servo motor, a DS18B20 temperature sensor, a Raspberry Pi 3 microcontroller, a 500 watts fan heater system, HCS004 proximity sensor, a computer, as well as an Android phone. So the working of the PRS sensor is basically on detecting the thermal energy, and what it detects is the change in thermal energy when a person cuts across the field of view as shown in figure 1. Now the equation, the energy equation is given is equation 1. Or the equation 1 gives the energy which is generated by a black body per unit time per wavelength, and when you look at it you realize that the energy generated from the change in pulses is given by equation 2. The DS18B B20 temperature sensor has the schematic diagram as shown in figure 2, and it is a one-wire programmable device which allows multiplexing, and therefore it is very important in this particular research. Now, the temperature detection is given by equation 3. The Raspberry Pi 3 operational block diagram is given by figure 3. Then the HCS R04 works based on the echo principle, and that is given by figure 4. The person, or how the system operates is that when a person cuts across the field of view, radiation is detected. So motion of that particular body creates a variation in the intensity of radiation that is falling on that particular sensor, and this leads to a change in the output voltage generated. So the system is supposed to continue working for as long as there is an high output from the proximity sensors. That indicates that there is a person inside the building. But if there is no person inside the building, then there will be low output from the proximity sensor, and therefore the system is supposed to be deactivated. So if there is person and there is that high output from the proximity sensor, the system is supposed to be maintained on until the optimal conditions have been achieved, or when the occupants leave that particular room, after which now you will realize that the proximity sensor will give a low output. The system operation can be monitored online, whereby you can be able to know the level of temperature at any particular instant. You can know whether temperature are rising or maybe they are falling, as well as you are able to know the room occupancy. Now, the flow chart of the program is given by this diagram here, whereby the system is powered, and if there is motion, then the level of temperature is checked. If it is cold, you have the heater activated, and if it is hot, the fan is activated. And again, the delay time is allowed to give room for that particular person to enter. If they enter, then room occupancy, if the room occupancy is detected, and therefore the system is maintained on. If they don't enter, there will be no room occupancy detected, and therefore the system will be deactivated. After the optimal conditions have been achieved, then the system goes off for around 2 minutes, after which now reference is made again to be able to reactivate the system again. So the results from my research is that a prototype was designed and fabricated, and it proved to be effective in controlling the level of temperature inside a particular room. A dashboard was also designed, a mobile app was installed in an Android phone, and it was actually very accurate in controlling the system manually, as well as monitoring the room temperature, as well as the occupancy. The prototype was tested, and the results were also compared with some bit of theoretical expectations. This is the designed circuit diagram, as you can see it there. You have the Pi 3, you have the relay switch, you have the temperature sensor, the proximity sensor, the LEDs, the heater, and the servo motor, which serves for the opening the windows. And after the integration of the different sensors, you have figure 5B. Then the prototype, after being designed, is given by figure 5C. Now, several factors determine how long an AC is supposed to take in cooling a particular room. We are looking at temperature and humidity outside. You are looking at the size of the room, size of the air conditioner, heat sources inside the room. They also play a major role. We are looking at sources like AC sources, electronic appliances, people, and so forth. So then we're also looking at insulation properties of that particular room. Now, the cooling capacity of any particular room is defined as the heat load in a room which needs to be removed. And that is determined by the temperature and humidity. Or that the required preset temperature and humidity are 24 degrees Celsius and 55% respectively, according to Passy et al. In 2020. And therefore, we need to be able to calculate how long an AC should be able to take. And therefore, first of all, we are looking at the number of occupants and to be able to determine the heat generated. Under normal office activity, a normal person generates 147 watts. So assuming that we have n occupants, then you have 147 times n, which is equal to K, and that is given by equation 6. Then based on the volume, we multiply volume by 6. And to explain the constant 6 here, according to Karachi and Theoclitos in 2012, when an AC is running normally, or at the start, it is consuming 6 times more energy as compared to when running steadily. That's why we are multiplying 6 by V to give us equation M. So adding M and K now gives us the estimated cooling capacity. And this equation only holds on condition that heat from other sources is negligible. And therefore, when designing an AC, it is very important that you create an allowance to be able to accommodate that. So efficiency of any system is very important. If at all, we have to be able to adopt that system to be viable. And therefore, equation 8 gives us the input energy. Then equation 9 gives us the output energy, and therefore the efficiency in terms of work output over work input can be given and was found to be 55.95%. So the implementation of this kind of a system actually can be a great boost towards automation of air systems. And again, it is a system that can serve two purposes in the sense that it is cost effective in terms of operation and installation, and can serve two purposes in that you can still be able to use it as a monitoring system. Existing systems have efficiencies ranging from 10 to 17%, with the highest ranging or reported being 23.45%. That's according to Young et al. In 2016. Now, the efficiency of this prototype was found to be 55.95%, and therefore, when you look at it, you realize that it is way being 23.45%. That's according to Young et al. In 2016. Now, the efficiency of this prototype was found to be 55.95%, and therefore, when you look at it, you realize that it is way far much above the 23.55% AFAC efficiency reported so far. And therefore, implementation of this system can actually be a great boost. Now, the response of the PIR was found to be 8 meters, and the response of the ultrasonic sensor was found to be upward distance of 4.56 meters, with an angle as low as 5 degrees Celsius. And that means it is actually very effective. So figure 6, what you have there is a dashboard which displays the room occupancy, as well as the set temperature, as well as the operation mode, whether auto or maybe manual. Then you also have the room temperature displayed in terms of a graph on the same Android app, and the response of the system can actually be detected there. So in conclusion, we are saying that an energy efficient smart AC was designed and fabricated with an efficiency of 55.95%. The system is able to detect a person approaching a building, and the system is able to detect room occupancy as well as temperature inside the room, as well as having an Android app which can be able to monitor all that. So several recommendations have been made. One is that advancements can be made on this system to be able to make it more efficient. In that, first of all, a camera can be integrated for face recognition as a security, or that means that the system can serve as a security system. Access to Wi-Fi is limited within the premises in which the system is actually installed, and therefore we can look at ways to be able to increase the access from remotely from outside here. Then possibility of more sensors coming into the system, like radiation sensors from electronic components, to be able to detect when the exposure goes beyond the recommended values. Then again, things like thermal guns at the entrance in line with COVID-19 protocols can still be evaluated. So I wish to acknowledge my supervisors, Dr. Nyenge and Dr. Muji, for their guidance, as well as my family for their support in this research. Thank you for your audience.
Thank you, Mr. Kavita Dennis, for sharing your study. Currently, he is not online. If anyone in the audience have any query, you can email us on conference ID. It is our pleasure to invite our last presenter of the session from Hamdard University to share his work on review of research work related to loss of power due to incorrect inclination on photovoltaic module through a recorded video. Please welcome Mr. Muhammad Ahmad.
Thank you.
Assalamu alaikum. My name is Muhammad Ahmad Shoaib, student of Department of Electrical Engineering, Hamdard University, Karachi, Pakistan. My topic is review of research work related to loss of power due to incorrect inclination of photovoltaic module. First of all, I will start with introduction. The process of converting the solar energy into electrical energy with the help of the solar panels is known as photovoltaic effect. Solar energy is a clean energy, it's a pollution-free energy. Tilt angle plays an important role in solar process. So tilt angle must be calculated and should be accurate so that you can get a maximum output power. Tilt angle must be equal to the latitude of that given area. In winter season, the tilt angle must be greater than the latitude, and in the summer seasons, the tilt angle must be less than the latitude. Solar irradiance is the light reaching out to the earth from the sun. In atmosphere, its value is 1368 Weber per meter square, but when it reaches to the Earth's surface is reduced to approximately 1000 Weber per meter square. The power density will always be at its maximum when the PV module is perpendicular to the Sun. The angles between the Sun and a fixed surface is continuously changing. The power density on a fixed PV module is less than that of the incident sunlight. As temperature rises, there is a slightly change in current, but voltage drops with the increase in temperature. Irradiance increases, current will start increasing, but voltage will drop because when irradiance increases, temperature will also increase. As temperature increase, voltage will start dropping. Aim of research paper. We have covered last 20-year papers regarding tilt angle and orientation. Different researchers have used different models, methods and techniques to calculate the losses due to incorrect inclination. We have summarized some of them in this paper. This review paper will help the researchers to study the losses due to inclination angle in PV module. Solar altitude angle model for efficient solar energy prediction. Visible sky is 180 degrees during an average half-day period, more in summer and less in winter. As Earth is continuously revolving around the Sun, the inclination angle between the Earth's surface and solar panel is continuously changing. So this change will affect the output power. The next paper is the effect of tilt angle on the solar panel output. With the increase in solar radiation, the output power will also increase. As more irradiance will fall on the surface panel, there will be more voltage and more current. Next one, a demand-based optimum solar panel orientation. As Earth is continuously rotating around the Sun, as there are different seasons on Earth, fixed angle will lead to the decrease in irradiance. When irradiance will decrease, it will affect your output. Data analysis on solar irradiance and performance characteristic of solar module with a test facility of various tilted angle and directions. In past 2 decades, several researchers conducted a study regarding tilt angle and their effect on the performance of PV module. The output mainly depends upon the irradiance and tilt angles. Sufficient data was collected from testing facilities and reported. Performance evolution of photovoltaic modules at different tilt angle and orientation. The output performance of the monocrystalline PV module in hot environment of Egypt was theoretically examined on different tilt angle and direction. It was further simulated on trenches. The optimum tilt angle was suggested between 20 to 30 degrees. The optimum tilt angle and orientation of photovoltaic panel in Şanlıurfa, Turkey. They have developed a mathematical model to analyze the performance of the solar PV module. Minimum change in tilt angle of 13 degree was observed in the June, while maximum change of 61 degree in December. Determining optimum tilt angles on photovoltaic panels at typical north tropical latitudes. A relationship between latitude and optimum tilt angle was found. Tilt angle should be changed twice a year to gain a maximum output. The gain of single axis tracked panel according to a extraterrestrial radiation. By increasing the latitude, the irradiance will decrease. Output energy of a photovoltaic module mounted on a single axis tracking system. They have compared performance of fixed panel with a single axis tracking system. Single axis tracking system has a better performance, but it is costly. Determination of the optimum tilt angle and orientation for solar photovoltaic arrays. This paper suggests a simple and universal method to obtain the optimum tilt angles by estimating the monthly mean daily global solar radiation on tilted surface facing directly towards the equator. A useful tool was proposed in order to set the modules to produce maximum output by yielding different tilt angles with specific consideration. An AND direction hybrid differentiation of evolution algorithm in determining the tilt angle for photovoltaic modules. An algorithm was proposed, namely AND direction hybrid differentiation evolution. It was based on mathematical model to calculate the best direction of sun to gain maximum output using Julian dating procedure, optimizing performance of photovoltaics in Reunion Island tilt angle. Energy plus software and Gent of software are used with Hook GV's optimization routine. It was found that the tilt angle has a significant effect on the performance of a solar panel. case study showing that the tilt angle of photovoltaic plants is nearly irrelevant. It was concluded that the tilt angle has no effect on the performance of a solar panels. Generation characteristic of 100 kilowatt PV system with various tilt angle and direction array. The system consists of 7 polycrystalline silicon arrays and 3 thin film arrays. Optimum tilt angle was found to be 28.4 degree and facing due to south. Optimization of tilt angle for solar panel case study for Medina, Saudi Arabia. By placing the solar panels on optimum conditions, there was increase in 8% in output. Optimum tilt angle and orientation of stand-alone photovoltaic electricity generation system for rural electrification. Panels are placed on optimum tilt angle, 6.4% gain was observed. Optimum fixed orientation and benefits of tracking for capturing solar radiation in the continental United States. Optimum tilt angle and azimuth angles varied by 10 degree from the rules of thumb of latitude and the south azimuth. When we compare a fixed tilt angle with a 2-axis tracking panel, there was an increase of 25 to 45%. Effect of manual tilt adjustment on incident irradiance on a fixed and track output power for winter season. Steady angle decreased power output by 1.5 watt numerically investigated. Asadullah 6.6% improvement observed by installing at 4 different tilt angle on 1 year time span. Mustafa Zahin 34% power output will be increased by using artificial neural network. Amin Khoda Karam Tafti effect of dust was observed with the respect of different tilt angles. The review has allowed analysis of several measures consecutively applied to achieve the best output on the electricity system for solar system. The optimum tilt angle is low in summer and spring and higher in winter and autumn. The photovoltaic system have shown a great gain in the system that use optimum yearly tilt angle where the tracking system is not preferred design because in developing countries there is a leakage in maintenance. Object of the research is to review different techniques for optimizing the tilt angle. Experiments and calculations were performed on various PV panels with different factors and techniques at various locations. Thank you.
Thank you, Mr. Mohammad Ahmad. Currently, he's online with us. So any question from the audience? Okay. Sorry to hear that. He's not currently online with us.
So if audience have any question, they're more than welcome to email on the conference ID. Now that all the presentations and speeches are ended, I would like Dr. Muhammad Amir to give his reviews on the session.
Bismillahirrahmanirrahim. First of all, once again, congratulations to Department of Physics and the University of Engineering and Technology for conducting first ever conference, which we are witnessing from yesterday. And it is a wonderful event. And obviously for the students, I could see that the students are taking very keen interest and listening to all presentation very patiently and with great interest. So in this technical session, I think there were 7 technical papers were planned to be presented, but I think 5 have been presented, including one keynote speech for which I already presented my comments. So starting from the first paper that was presented by Mr. Tariq Jamil from GIKI, it was regarding improved optical performance of AI GaN UVC LEDs with introducing PAIN electronic blocking layer. And I would like to give few comments. According to the authors, the study provided a realistic approach for the development of highly efficient UVC LEDs, obviously ultraviolet LEDs, for disinfection purpose, which has great value in this current wake of pandemic. So it was a good study, and I don't know about the practical implementation, but I think students were taking keen interest, and the presenter covered everything related to previous work and made good contribution and good comparisons. And the second paper presented by students of Syed University regarding quantization error in time to digital converted. According to the authors, the analysis of results lead to the conclusion that in some particular conditions, the influence of the quantization error on measurement and uncertainty can be minimized by statistical averaging. The proof of concept was not very much clear because the presentation was very short. But obviously it was effort by some students. At number 3, a survey on wireless sensor network and cryptography was presented by students of Syed University. As you could see, it was only a survey-based paper which introduced not only the basic concepts of the wireless sensor network, but its relationship with different cryptography algorithm. In fact, number of cryptography algorithms starting from the classical to the state of the art were covered. So maybe it was quite interesting for the students. At number 4, our guest from Kenya joined and presented optimization of air conditioning control to enable energy saver. And according to the author, an overall energy efficiency of around 55.95% was achieved as outcome of their proposed solution, and it was also claimed that the proposed solution is cost effective as compared to available solution in the Kenya. So I think it was a good effort. And in the last stage, the last paper of the technical session was contributed by the students of Hamdard University, in which different methods of tilt angle and orientation of photovoltaic modules were reviewed to propose an optimal solution. So it was a review paper in which so many techniques and different drawbacks and different benefits of having different angles in different months of the calendar year were discussed. So overall, it was a good session, and I'm thankful to Dr. Irfan Ahmed and the whole management of the conference for inviting me as chair of this technical session. Thank you very much. Allah Hafiz.
Thank you, Professor Dr. Muhammad Amir. We'd like you to stay on stage. Dr. Irfan Ahmed, Conference Chair, please come forward to present memento and souvenir to our session chair. I like Dr. Imran to come to stage and present our session chair with memento and souvenir. And I also like Syed, member of Electromates, to assist Mr. Imran Ahmed. Certificate.
Okay. E-certificates will be provided to each presenter online. I would request.
I would like to thank all our faculty members, presenters, speakers, and audience for their participation and presence. It is on occasions like these that we get to have the idea and insight of how the best and beautiful brains think like.
All guests and participants are requested to move outside the auditorium for tea. The next session on women in physical science will start on 11 p.m.
Thank you. I don't know. मेरा पानी पी लो। मेरा पानी है ना? मेरा पानी है।
Kindly settle down. We are starting.
Everyone is requested to have their seats. Settle down, please. We are waiting for everyone to get settled down, please.
Welcoming you again at the first International Conference on Applied Physics and Engineering. I'm Shahrukh, student of Department of Physics, NAD University.
I'm Rabia Batu, the final year student of Department of Physics, NAD University. We're going to host the session, Women in Physical Sciences. The session aims to give great honor to the contributions made by women all over the world. I feel extreme privilege to welcome you all at day 2 of the International Conference on Applied Physics and Engineering. World progresses by making advancements in different fields and by allowing females to contribute in the respective fields. Women, no doubt, came a long way improving the numbers and increasing the percentages in the work frame of physics and technology. Over the past century, women have made remarkable contributions in the field of radioactivity, nuclear physics, astrophysics, and astronomy. I also want to take the names of some Pakistani women who changed the face of physics by making notable contributions to the field. They are Nargis Mawalwala. She is known for her breakthrough research in gravitational wave dissection in 2015. She also received the Special MacArthur Award in 2020. Tasneem Zahra Hasnain is the first Pakistani woman who has worked on string theory. She presented Pakistan at the meeting of Nobel laureates in Germany. Talat Shehnaz Rahman, a condensed matter physicist, has done research on catalysis and vibrational dynamics and magnetic excitation. These are just the contribution of 3 out of many Pakistani female women.
I would like to call Dr. Sama Yusuf on stage and take her seat. And I would like also to call Dr. Shehnaz Parveen to come on stage and take her seat as well. I would like to call Madam Aziz Fatma also to come on stage.
Thank you so much, Dr. Samar Yusuf and Dr. Shahnaz Parveen.
Ladies and gentlemen, I would like to introduce our first invited speaker of the session. Please give her a warm welcome. Dr. Samar Yusuf.
Firstly, I want to introduce, we really want to introduce before inviting you. Dr. Samar Yusuf is a professional at HEG Institute of International Center of Chemical and Biological Sciences. She is one of the most aspiring young female scientists in Pakistan and has authored more than 200 research papers with more than 2,700 citations. She is the pioneer of crystal engineering in Pakistan with her research on crystallization, making it to the cover page of an international science journal. For her achievements, she has been awarded Regional Prize for Young Scientists at Third World Academy of Sciences. Please, ladies and gentlemen, give warm welcome to Dr. Samar Yusuf.
Assalamu alaikum, ladies and gentlemen, and good morning. Thank you so much for the organizers to give me an opportunity to be here to share with you some of the thoughts of the women in science. When I was approached by the organizers to give a talk, so I discussed with them and they want me to give you some inspirational talk. So I divided my talk in 3 parts. In first part, I will talk about the science, the contribution of science contribution of women in science in general. And then in second part, I will share with you some inspirational examples from the worldwide and from the Muslim world. I will talk about by myself, how I proceed in my career. And in the last part, I will give you what opportunities ICCBS is offering women to excel in science and what Comstech is doing to in the OIC world for the promotion of women in science. So let's talk about science, often considered as a male dominating field. Let's think about that in this modern era, in this 21st century, why science is still a man dominating field. I took this very recent survey published by the United Nations data that still less than 30% of the scientific researchers worldwide are women. Why? I invite all of you to think about that what is the reason behind why the women worldwide, and especially in your society, are a little bit reluctant to accept the challenging jobs, challenging research to operate as their career. One of the reasons they give by themselves in this survey, they said that women are reluctant and discouraged from or become less interested in entering the fields of science, technology, engineering, and other fields just because of the reason that from the beginning, at a young stage, they are discouraged. This is, I invite you to think about that. Anybody in your family, when you were young, when you was preparing to going to the school, and there was a talk in your family regarding your career and all the things, did somebody recommend you to be a researcher, to be a scientist? I can bet on that not a single example existing in this hall. The reason is that we are not considering the women in the science as an inspiration, as a role model. So there is a need that right from today, you start talking about the researchers, women in your family, so that your family start adopting, and your young brother and sisters, and especially the young girls in your family, start thinking about that they can adopt the research as one of many options they have in the career. Even in the US, considered as a role model, the most modern society. Women are underrepresented in engineering, computer sciences, and physical sciences. Let's have the look of these matrices. They compared it by the employment they hired in 2020. And you can see here that even in maths, physical sciences, and engineering, the women employees are underrepresented. So keep in mind that whatever the issues I'm talking about, particularly in Pakistan and outside the Pakistan, in broad spectrum, they are not only the issues of the women in our society, but they are the issues worldwide. If we talk about in global scenario, you can see that number of young women in campuses, research institutions, and industries has grown steadily in 3 decades all around the globe and also in the OIC member countries. If we talk about the UNESCO report on education published in 2018, so you can see the scenario is going to be changed, that in 1970s, the overall global scenario was that 100 males per 35 females in the research and industry, in research and other departments of the universities. But right now, I am presenting here the data of the 2017 because I couldn't find the most recent one, but the number has steadily increased. I'm confident on that, until 2017, it was 48 females per 100 males. So you can see that this gender difference ratio is going to be minimized globally. But still, there are the women who are reluctant in some other disciplines like engineering, maths, physical sciences. What are the reasons behind that? Women are welcomed and they are encouraged to opt the academia industries today in developing world, and more women likely to join academia and research and development institutions. But the balance is towards academia more than that research institutions. Why? Why the increasing number of women professionals prefer to opt academia and followed by the research positions? Think about the society behavior and the problem they are facing. Number one, flexibility in working hours. I will talk about later in detail about this. Relatively less peer pressure. If they are a teacher, they have less pressure as compared to those who are doing research or those who are at commanding position in their organization. You will listen Dr. Shahnaz Parveen about that pressure. And then they are opting academia because they are familiar with the environment. And of course, the matter of salary is matter for all those women who came out from their houses just to support their family. But beside all these challenges, all the cultural impediments, gender discrimination, lack of recognition in their scientific community, still there are the countless aspiring examples of the women in physical sciences that make remarkable change and historical contributions and change the whole paradigm of that specific science. For example, this Dorothy, I always love to talk about and to read about Dorothy because I am working in single crystal X-ray diffraction, and she is the lady who won Nobel Prize in chemistry. She is the lady who solved for the first time the X-ray of any biomolecule in the history of the world. She did the X-ray of DNA and decorated by Nobel Prize in that. Grace Hopper, she was a computer programmer and first programmer of the modern computing age. She is considered for that. Liz, she was the first woman to become a physics professor in Germany. And keep in mind that in Germany, to be a professor, even in past time, it was and it is not an easy task. Professor Wu, she is a Chinese American physicist who changed who actually disproved the basic law of physics called as conservation of parity. And she proved that, and we always talk about that the mirror images are non-distinguishable and they always behave in a similar way. But she proved that when you are talking about a radioactive material, so the decaying process is not similar. And one sad example from the Western world. that this Maria was a pioneer in German astronomy, but unfortunately her work was published by her husband without mentioning her name. Let's move towards the Muslim world. I just took very quick and examples that women in higher education in at least 10 OIC member states like in Pakistan, India, Iran, Malaysia, are higher than that countries such as Western world, that is Switzerland, Germany, United Kingdom, and all other. On the other hand, women in STEM professions are still low, even in some OIC countries. Like Aisha, she's an Egyptian and she's a computer scientist who is specialized in ad hoc networking. Anusha Ansari, she is an Iranian girl who was decorated, who was captured by the headlines in 2006. And she is the first female private space explorer. And in the world, she was the fourth one who visited a space in private capacity. She is not a physical scientist, but it's worthy to mention you from Malaysia, that is Professor Khatija. She was accorded by the UNESCO Carlos Finele Prize for Microbiology in 2005. And at that time, she was the second Asian scientist who received such an honor. And from Syria, she is based in UK, and she worked on the physics of the solar corona and solar flares. Let's talk about the Pakistan. If we are talking about the current scenario in our academic institutions, the number of female students have grown substantially in last 3 decades. The gender ratio, again, I'm going to mentioning you the UNESCO report that the gender ratio for higher education students is now 80 males per 100 females. Compare it in 70s when there was only 300 males per 95 females. So the paradigm of higher education institution is going to be changed in Pakistan. And the numerical imbalance between male and female is growing with every passing year. Okay. And if you feel that this is an exciting time for the women in Pakistan, in the national history, that we have women in higher education, which are both exciting, inspiring, and coming out of the shadows of illiteracy and cultural impediments. But think about those when you get completed your higher education and you are going to opt in any career in your life. I wanted to give you the 2 examples and then move slowly towards our society. Like Aliza Sharif, a very young girl who has developed a drone for the emergency medical care. Or Rida Ayub. Both of these examples are actually the incubatees of ICCBS Technology Incubation Park. And she has made a solution, a smart solution, specifically designed to reduce billing queue from outlets. So these 2 inspiring examples are for you. If you have developed a thing, or if you are with an idea of product, just come and approach our technology incubation center, and they will provide you the space, and they will give you the guidance that how you can proceed further with your product. It's not moving. Let's think about that. Whenever you are going to opt in a career in your after completion of your education. So what will be the role of society? Your environment is actually giving you the opportunity or the resistance. Both of these options are moving side by side, because you are not only a woman. Women is not only a woman. It's not. Okay. Women is a mother, is a sister, is a wife, is a friend, and other relations. So what your society is doing with the women? Are they promoting you? Are they give you the equal opportunities as they are providing the men in the family? Just think about a mother, because all of us are convinced 100% that mother are the one who is providing you, who are actually building the next generation for you, for the nation. So the responsibility of mother is not only to brought up their children, but to teach your children, to teach son that how he respect the women around him, whether he has a sister or mother or any other relation in the family or any colleague, or the one to whom he don't know anything, but in front of him there is a girl, a woman, and he need to respect him a lot, to respect him in a way that if he is a head of an organization, so he should provide them, facilitate them under his domain. And on the other hand, there is a responsibility of a mother to give the strength of their girls, of their daughter, in a way that they can survive in this resistant society. But come back to the career, come back to the science. If a mother is bringing up a child, bringing up children, is our society is providing them the enough space to do that in addition to their career? Are we providing them the flexible working hour so they can brought up their children, they can give the time to their family and their career? Absolutely, we are not doing this. Are we providing them the daycare centers? Very important thing. If you are a mother, if you are a researcher, if you are opting any other career, so where you will leave your children with peaceful minds, so you can do your research and you can proceed in your career. And are we providing them the nursing room during the working environment? We are not doing actually. So these are the hurdles, these are the difficulties which our society and our organization is actually giving them to proceed further in their career. But exceptions are around you. There is always exceptions who fascinate you, who survive in this difficult scenario, all these being a woman. And I'm now going to giving you the example of myself. I'm not presenting here just to take a wow from you, but you just think about that women can survive. If she's strong enough, she can survive in even a very difficult situation. You just saw me, my physical inability, although it is not too much, but it was not too much since 1998 when I was get operated. But before that, the role of my family was very important. But before that, if you're gonna opt a career in your life, or you are being a researcher or a scientist, keep in mind hard work, commitment, and strength. These three things will keep you nourished and will take you to the level best in your career. I'm a professor of chemistry in International Center for Chemical and Biological Sciences, University of Karachi. And what is in my credit is that I was get trained by my organization in this specific field, and they give me the challenge to develop the first crystal engineering lab in my institution. I did that. I not only established that lab in the institute, but also I published the first ever paper in this emerging field from the Pakistan in very reputed and respected journal in the field of crystallography. In addition to that, these are my credentials. But this success story is not the story of mine, but these are the stories of all those who give me the opportunity, who give me the strength, who encourage me to do that. My family, my parents. I was infected with polio when I was only 1 year old, and I was among those children who couldn't be able to took the first step of my life till 4.5 years. And my father was the first one who took the step in the family and clearly mentioned that I will spend all of my efforts on the education of my daughter, because education will be her weapon and she will beat the world with this weapon. And my elder sister, she was always during the school and even in the college with the 2 bags, one for her and one for mine, because I was not able to carry the bag at that time with me all the time. In addition to that, I completed my education and then I higher education and I proceed to operate the research. So the role of your mentor, your teacher is really very important. And I'm proud to be a student and to be a part of the team of Professor Muhammad Iqbal Chaudhry, the person who is the courage and source of inspiration for me. He always encouraged me whenever I approach him for a suggestion and for as a teacher. He is the person who always encouraged me. And being a head of an organization, he always encourage us, not only me, the other female researchers also, with excellent research facilities, with merit-based training opportunities, and for safe and comfortable environment. Keep in mind this safe and comfortable environment, especially for the women, is very important. I used to work even in middle at the night because my machine is running 24 hours. So I'm in charge of that facility. And I used to have a keen eye on that system. So when even in the middle of the night, I am very free, feeling safe and comfortable to get in my campus, to proceed my lab and work there. So look at this, that establishing a strong safety and security culture is one of the fundamental management principles for an organization. Such a culture influences the organization's structure, style, as well as the attitude, approaches, and commitment of individuals at all levels in the organization. So this is the responsibility of an organization, that they should provide you the safe environment, so you should work with peace of mind. So what I would recommend, invite you to think about, if you are a woman, so being an organization, there is a responsibility of organization to provide you the hostile working environment. This is the major issue of our women to excel in our society. We are always with lack of recognition for women. So our organizations need to think about, as I mentioned earlier, we need to develop, we need to provide them the daycare centers. One more thing, maybe some of them will not in front of me, but maybe some of them will laugh about it. But as the number of female students are growing, are rapidly increasing in our institutions, but we are not thinking about that we should provide them even the washroom more now than that of the male. But unfortunately, more of our campuses are old, and we are not providing them that. We should modify our KPIs as per need of the women. We recognize them. We hire more women and nominate women for awards and leadership. And of course, we would give them an opportunity to meet with role models. So I talked already about the a technology park. These are the few scholarships for the women which we are providing. And if we talk about the ComSec, perhaps the most vibrational organization in the OIC world, who is working for the science and promotion, not only in the Muslim world, but particularly with women also. So there are the major programs which they are offering. And in each program, they always care about the gender equivalence. So if you have an opportunity to join their workshop or their ongoing facilities, please do ahead. And there are the other opportunities for women for science and technology and for research. And thank you so much for your patience.
Questions. Now, audience are requested to ask any question if they have any. Do we have a question? Thank you, Dr. Sama Yusuf, for your engaging and inspirational speech. Today, we have the great privilege to listen to a speaker who not only made great advancement in the field of physics, but also a woman who treasures knowledge. She's not only an incredible physicist, but also a visionary who is working relentlessly to encourage women in the field of STEM. She's a human manifestation of the phrase, if women do not get the invite to a seat on the table, then women need to create their own table. Ladies and gentlemen, she's live with us. Please give warm big welcome to Professor Dr. Noorun Nahar.
Assalamu alaikum, and thank you for inviting me to this session. I just heard the previous. Thank you. It was a wonderful presentation by Dr. Yusuf. I really enjoyed it and all the information. So I'm going to talk something similar, but it will be different. So I'm going to share my presentation. This one. Okay. So the title is International Society of Muslim Women in Science. I'm going to talk about this, but before I do that, I intend to say something more for everyone, not all the female participants in this conference, but all the male and everyone. So this is to join the American Physical Society. The American Physical, it is the largest scientific network. It has over 55,000 members, not only from USA, from all over the world. So I'll just go briefly. I have some slides. It has made a number of divisions, and now they will match one of your area. It has sections of which may not be of interest because it's largely in the US. It has topical groups and forums. Okay, so all these things are here, and there are many benefits to become a member of the American Physical Society or APS. You can submit abstract, and if you're not able to be in the US, your collaborator and someone else can present it on your behalf. It is a great place for networking. And not only that, you can get scientific news, announcement, job alerts. You can get free Physics Today, APS newsletters, yearly calendar. And not only that, you can post your CV at APS website once you become member. And if your CV is there, then you'll find lots of job opportunities in the career web page. And if you apply from there, you can connect your CV directly to your application. Not in that, APS also helps, gives trainings to how to apply, how to go for interview, job training. It has all advantages. It has grants for various projects. It also gives a lot of awards. So even it can issue a letter for the visa. So there are many benefits into it. Okay. So, but the membership is high, $160 per year for us. in the US, Europe, and Canada countries. So I become an elected member in the executive committee of one unit of APS. It is FIP, Forum of International Physics. So this is the team member. So I entered that to committee to serve. I had just one objective, to bring the scientists or physicists from the Arab world and the Asian countries, because they represent poorly at APS. Then I submitted my proposal, but there are issues. Then I found out that there is a scope for free membership. And that was very much hidden with a lot of restrictions. So I campaigned for it for 2 years to open it up or give discount membership to everyone. So I got remarks like that, Sultana, this is not World Physical Society, this is American Physical Society. However, anyway, after 2 years of effort, so the person in charge, she said, Sultana, go ahead and bring your people. And I did. I have brought people from 29 countries, to APS membership. So Pakistan is one of them who can get free membership. How to get free membership? It is very difficult to find that particular application, but the application form is at my website. So anybody can download it, fill it out. All you have to do, fill out the form, attach your CV, and don't spend any money, just email both to Jennifer Pirnet or Jennifer Roberto. The email address is also given, the two addresses are given here, and you will hear acceptance in a couple of weeks. So it is going on since 2014, and I would like everyone who are not only at NED, University of Engineering Technology, participants in this conference, and not only physicists, but anyone doing something related to physics, apply for it and get the membership. And for a student, it is free for 1 year, but if you use that form that I use, it will be free for 4 to 6 years. And not in that, you can renew it, the membership once it is over. So you can keep on renewing it and be member. Okay, this is the form at my website. It's a very simple form. Only one place there is you have to write a personal statement why you want this free. It's something called fund program. Okay, why do you want the free membership? Then you need to write down the reasons. What I did, I wrote down a bunch of reasons and put them at my website, but not explicit. You have to click on it. If I do everything open, APS can come after me. So you click on that, you find the reasons and put the reasons right here and then apply. So I'll invite everyone to apply to APS. Okay, so once you get, you'll get your ID and they become members. You can be members of 4 units without any extra fee. Once you become member, and you can start enjoying, you'll love APS once you become member. So that is all I wanted to say to everyone at this conference and university and whoever is there. All right, now I would like to say whatever Dr. Yusuf was saying. Yes, she looks like a very inspiring person. So STEM, she mentioned about STEM. So STEM, why do we need STEM? Because it's part of life. It is needed for advances for humanity and survivability. And the knowledge we get, it is, we can solve the knowledge, we can use the knowledge to solve problems we face, like COVID-19 pandemic, climate, space explorations, health, agriculture, and the knowledge gives us the control to shape our future for the best. And why females are so important? Because we are half of the population and we are half of the intellectual power of this humanity. So we cannot waste our brain and the power and not be part of the advances. Okay, and just for encouragement, I like to say that, know that Muslim women have been in forefront in many respects, to encourage education. The oldest university, when I was a student, I knew Al-Azhar University is the oldest known university on earth. But no, there is an university in Morocco. and it's called Universitat Al Qurainin. This is the university, is the oldest one. It is more than 1200 years old, and it was established by whom? Guess whom? It is a Muslim woman. Her name was Fatima Al-Fihri. Okay, so we can, there are other examples like Cairo University itself was established by the princess of Egypt. So, and also at this time, we have the largest university, female university, that is in Saudi Arabia. People think people are not encouraged, women are not encouraged to go to school. Well, they're coming, okay. So this is the largest university at this time. It has, I visited it and gave a talk in ISMWS, the International Society of Muslim Women in Science, in 2014. It has over 60,000 students, and the faculty members are eager to do scientific research. They want to collaborate, but and they have very high-tech labs, largely for education, but at this time, I think they have more advanced labs, but they do not know how to be a strong partner with the modern world, or the, say, Western world. And Muslim women also face more obstacles, because the way we are, and we also have less resources for research. Okay, so I attended an international conference. It's called Modern Trend in Physics Research in 2018 in Egypt, which changed me. And this is the first Muslim country that I went for a conference. So this is an Egyptian museum that time. This is my son. When I attended the conference, and I saw people coming from, the species coming from Africa, Middle East, China, India, and the USA. The USA, very few. And then I met, all these modest, inquisitive female scientists. They are isolated, but very devoted. And they have very little collaboration with outside. They work on their own in their labs and a long period of time. They are not even aware that other female Muslim scientists in the field. And they face significant difficulty in collaborative research, to go outside. They don't know how to connect. And also sometimes, like in Saudi Arabia, for example, if you want to connect, collaborate with a man, it's extremely difficult. There's a lot of ways that you have to cross before you can find a collaborator. All right. So, so there's in this picture, there's a person who inspired me a lot. I don't even remember her name. At the conference, she's the one. She was always with me. Wherever I go, she'd be following me. I thought she was a PhD student, Egyptian. I didn't know where she was from. And he's an Iraqi professor. So before she was leaving, she came and shook my hand, and she told me she was very, very nice to meet you. I enjoyed, she said something nice. So I answered, so I'm also very pleased to meet you. And are you a student doing? She said, no, I'm a professor at University of Khartoum in Sudan. And then I talked, she's devotes so much time on her own in her lab, and she's trying to do whatever she can. And after coming back, she kept coming to my mind, and she inspired me to think, what can help her to do better research and pursue her dream? She's continuing, whatever she can. Okay, so then in 2000, that was 2008, and 2009, there was an American professor, Dr. Connor. She is a faculty at United Arab Emirates University, and there was there was an university-wide event, and she asked her science female students just to project some female, prominent female. So they found poet, they found a few philanthropic men, but they could not find any female in science. So, but Dr. Corner, she's the one. Then she finally found me, contacted me, and made an arrangement for the interview. So, but a number of students interviewed me, and they made this presentation, which later on Dr. Connor sent me. So it's a Dr. Sultana Nahar, the Iron Lady of mathematical computations. Whatever they understood, whatever they present, but main part was that they, at the end, their conclusion they wrote women are smart. See, these girls, they don't have any exposure to that much science. So, and I became very curious. So in 2011, I visited that university and I gave a couple of talks. I was looking for the girls who interviewed me. I was very pleased to see the person who interviewed most, her name was Amira. She was a lecturer in the math department. It was very pleasing to see her. So these are like all abstractions. So, and that I also found that science is not encouraged in many countries. Pakistan looks like it's very good. Indonesia is way behind. So science, natural sciences are used as the basic for applied physics, engineering, computer science. So she's the one, she's the ISM member of our society. She's the only one, okay? She came to High Street University, became member, and there's no other person. So one OSU faculty connected to Indonesia put this page up to contact me for APS or Women's Society information. Nobody contacted me. So, but she doesn't have any connection to anyone outside, any research person. So before, okay, I just have to say one thing. So we say, outsiders say that Muslim women, I know they are only burqa and they are not encouraged. But this picture, I just want to show one lively thing. This is the Aligarh Muslim University Sultan Jaha Hall for female students. So I was invited and I was handing out the prizes, first prizes of the cultural events. You won't believe the way the girls participated in fashion show, dancing, Bollywood, energetic, they can win any competition, but it was very secluded. No man was allowed. The third person who got this dance prize, so I was holding, she came to me with cartwheels. She's a gymnast. She came and got the prize, and I met her after 2 years. She was doing her master's in abaya, full abaya at JMI in biology. The second prize went okay. The first prize was announced, and I didn't see anyone coming to the stage. Then I look on the side, and I saw a girl with abaya. Okay, so actually she was very happy, shining eyes. So I said, "Are you the winner?" She just became so pleased. She said, "Yes, ma'am." So she got the first prize. Her parents are waiting outside. So she put on her abaya. But inside that abaya, and I just want to say this black, hijab or abaya they wear, they can be very modest outside, but they are extremely lively inside. That's okay. So with a lot of objectives, and I was discussing it, and a colleague of mine at Ohio State told me, "You are thinking of them so much, why don't you form your own society?" And I did in 2010. So objectives of the ISMWs is that we form a network to provide moral support, encouragement, retention, encouragement to retention in science and research, information on higher education, jobs, fellowships, secure grants. So all this information are given. Our motto for retention is the stay in science, basic or applied. Just make your effort to stay in science. And we practice, keep some hours for our intellectual nourishment every day. This is my practice. No matter how much I do, if Sunday, I'm spending some time with my family or my sister's house, but I will spend at least 2 hours for my own research. Okay, so we said every day we keep a couple of hours for ourselves. We need detachment, we need devotion. And we believe that the more we use our brain and mind, the more beautiful we look. At this time, our ISMWS has a chapter at Ohio State and at East Carolina University and Aligarh Muslim University, and also in Kashmir. And as it has been a research topic, particularly at OSU, but also I got interview call from Georgia Tech, Florida International University, and it has been featured at Western Washington University, Voice of America, American Physical Society, OSU Media, they become interested to what is this society and about Muslim women. And I've been giving talk on that and how to become a member of the society. Membership is free. Anybody can be member as long as you are in science. And the lifetime, there is no annual fee, and it is for lifetime unless the member wants to leave. All you have to do, email me your information. with your name, degree, which is a PhD or doctor or whatever is student, and research area, position, what is your student or professional in what capacity, scientist, institutional, company, address. I like preferably institutional, country, residence and nationality, and these are optional URL, but email is required. So if you do that, and you can visit the website, if you just go, say Sultana and Nahar, and go to my web page, there is a box saying ISMWS Global. Then if you click on that, you can see a lot of information. Okay, at this time we have, I think, over 300 members from 31 countries. So these are the 31 countries, and you won't believe all these girls, they are all physics students in Taiba University in Saudi Arabia. All right, what we do, our activities include lectures, networking. We do quite a bit of networking, connecting for scientific collaboration. I'll show some example. We share success news in ISMWS newsletters. We circulate useful scientific news, circulate scholarship opportunities and job openings. We help with information for higher education in the US, always celebrate International Women's Day, and give recognition for excellence. So this is an example, this observing International Women's Day at Aligarh Muslim University, all these women. And I don't know, it could be 2014. I've been doing it for quite some time. And this is, I think, 2018. And so we are giving, and she is from Iraq. She's getting this award certificate for being a promising scientist. All right. So this is in Cairo University, Ohio State University, and Cairo University has a MOA since 2012. Guess who was involved? Professor Lutfia Al-Nadi. She and myself made this MOA, and he's the Dean of Faculty of Engineering, Dean of Faculty of Science. They together we signed. The Vice President just left, and she is a member. So because of member, we connect with each other and do a lot of things together. So then Cairo University, we connected with Aligarh Muslim University for nanotechnology research. And when she was visiting, the Vice Chancellor, Zamiruddin Shah, gave her this plaque. So then this is our member from Morocco. So she is one, she is in the University of Dokal, University of Shoaib Dokali, but she has PhD, she has done, but research is very difficult. So she asked me to collaborate, but I didn't have so much, direct plasma modeling experience, so that I can give you the course. I give course internationally to many countries. So then it was organized through this innovation center, and Professor Hamdi, he is the director. And then, about, even though they are French speaking, that she was able to get in about over 65 participants joining the course. So we do that course. And then at Wayne State University, I was visiting there, and the chairman organized a particular session, and for me to representation or the lead the session for the physics women only. So you can see these are all the physics women in the department. I'm leading it, and you'll be surprised, the difficulties faced by the women, even in the US. And someone sitting here, her name is Carolyn Morgan Pond. She went to Princeton, but felt so much objection in the family. But she came out and became a faculty at Wayne State. And this is some impact. I would like to show here. This is Lala Nagma from in School of Mines of India. School of Mines, it is very prominent university in India. It has become IIT. So when she was a graduate student, she contacted me, and she became a member, and she wanted to work with me. And 2018, she got this fellowship, came and worked with me, and we went to this APS conference. And her dream fulfilled when she's standing by the Nobel Prize winner, because she listened to his lectures a lot from MIT. And so this is Rala. Another one, this is Munira from University in Saudi Arabia. She wanted to do some research, so I connected her to someone here, Professor Burchin Munirat Burchin. She's Miami University. She has a laser lab, and she wanted to do laser research. So Burchin called her, and so Munira came, spent some time here in the US. And after that, she came to Ohio State. So this is at Ohio State, and both of them gave talk. So Rala, then I also had a student who denied marriage in India and joined Texas University, and joined a big project. And this encouragement has so much impact on people. So after hearing my lecture, a mother of low-income family in Aligarh promised me to let her daughter study science. And this daughter has been asking her to let her go to science. Then I connected NIT Kashmir professor to Dhaka University, and introduced research scopes in Bangladesh, India, Morocco, Turkey, etc. So these are things we do. This is my student, Hala. She's at the National Institute of Standard Technology in Washington, D.C. at this time. She did her, I also brought her member, is from a student. She was at Ohio State. And this is another member from Palestine. She's the one is now Zara. So, she was at Cairo University. Yes.
I'm so sorry to interrupt you, but because of the shortage of time, I want you to wind up your presentation in a couple of minutes. And we are so sorry for that.
No, don't feel sorry. I appreciate that you reminded me. Okay. All right. I think we are going closer to end. So this is Soleha, the student, and this is the Islamic University in Gaza, where I have a program, and the recognition program, and these awards, the certificate holder, they're largely women. And then I got an award from the State Department of US to hold 9 workshops in India, and for minorities and disadvantaged females. Guess who? No, the largest applications came from the Muslim girls. So this is I think in Delhi. See all these girls, they're largely Muslim applications, and they came, and it was very encouraging. And I invited the prominent figure, who are exemplary. So she's Heptullah. She herself is an example, become professor at age 22 after getting PhD. And after this workshop, they sent a lot of reports. And this girl particularly, I like this picture. She wrote to me that I stood the first position among BSc students of my university after the workshop. So they have so much impact. Rifa Khan, she got very high score, and she wrote that whatever instilled me remains forever. The encouragement. There's another girl who wrote from a different university that my aims to be ideal for others like Albert Einstein, Abdul Kalam, and at least also she also named me. So this is Rala. I just want to say that we have a lot of issues. So Rala, whom I mentioned, is right here when she was at the Ohio State University. She went to this well-known university, and she has 8 papers during her PhD with her as the first author. Okay, in total, she has 28 publications. She was the only Muslim female in the science faculty. Even after doing all of this, she had also 3 dreams that she told me she can marry to a right spouse. Actually, by fate, she got married to the chair of the math department of IIT Indore. She wanted to write an important article, as she did when she was at Ohio State, Rala. And then she said she wanted to explore, when she was student, independence strength inside her. And when she was here, she came with a little boy and by herself and did her research, took care of the boy. It's a different country, not India. This is US. She managed excellently. But with all her credentials, for the last 3 years, she has not been able to find a job in India. So we have many cases like Rala. This is also something I like to say. We need to think how we can help nurture, not only that you should do the you study, also find somehow they can continue to do science and fulfill their dream. So that is all I'm to say, but I just want to say one more page. This is something I say, this is not necessarily, for only for females. I say for the Muslims, for our own dignity and stand, make a practice of this. Always help or support, regardless of my opinion, a person who is doing something productive. I don't like when you say bad things about someone, okay? So I say, don't say it. Make only positive comments about Islam and Muslims. If you have zero comment, remain quiet. Do not initiate anything. If you have a negative point to make against Muslims, be patient and be quiet. There are plenty of people out there to make negative statements. If you think supporting others against your own kind will do justice, know that it will not work. It may end like digging your own grave. And speak out our views forcefully but politely, and also listen to what others say respectfully, even if we disagree. We have to learn to live with diversity and opposition with respect, but keep our own identity. If we, the first Muslim making effort to be part of advances, be ready to absorb insult, put downs, non-cooperative attitudes, build a mental Teflon coating around you so that you can wipe off anything disturbing thrown onto you. The impact, you are the pioneer making the way for the next ones to go up. And I would like to say, remain united with Muslims and promote each other. Thank you.
Thank you, Professor Noor Naha, for your inspirational words. Our next lecture is from someone who...
Yes, sir.
Assalamualaikum, Dr. Munar. I'm Dr. Irfan Ahmed. We've been in communication for the conference setting along, and I don't have words to you for thanks. I cannot appreciate much. And I'm thankful for my membership to the American Physical Society for no cost because of you. So we remain continue for this in collaboration. Actually, when we are planning this, you heard me now? You are hearing me?
I can hear you.
Thank you. I said I am thankful for you that you provided us the free membership of the American Physical Society, and I opted and Dr. Hera opted, and we got it. Thank you.
I would like to say that please, if you want, I can send you the information. If you post it in the department so that others can apply, I would like to encourage others to apply. Okay.
Yeah. We circulated it, and people are coming for this now. But we benefited very quickly from your response, and we got the membership. Thank you very much. This session, Women in Physical Sciences, actually, when we were planning this conference, so we thought that we are benefited from women contribution, but it's not highlighted. It should be highlighted separately rather. So, and you and like other women supported us in this, the dignitaries sitting here and online. So I appreciate your contribution.
Thank you.
And you did a lot like offering us the endowment and other things. So the Department of Physics and Energy University will remain in collaboration with you for long, I assure you, on behalf of the Vice Chancellor and others. So I'm grateful, and I don't have much words. I don't have much words here. I don't want to take many time there. We'll communicate separately too. And Dr. Hera also has some question for you and something, I think.
All right.
Thank you.
But I appreciate your support, okay? I seriously. Okay.
Assalamu alaikum, Dr. Sultana. Thank you very much. Thank you very much for guiding us, for supporting us, for being there and accommodating for all the requests. I've been requesting you silly things. Please increase the time by 10 minutes, reduce it by 5 minutes, and so on and so forth. You have been very kind and supportive. It really means to have you on both days. You were here on the first day, you are here on the second day. Although there is a time difference, which is quite considerable, it must be quite late at night for you by now, I suppose. You have been an inspiration to me to see how you can work around 24/7. It's really inspirational and very kind of you. Thank you for all your support and for offering awards and the endowment. The MOA is now in process. It's been sent to syndicate for the approval. I hope it will pass through this meeting, and surely we will be then sharing with you the official documents for that. Thank you very much, Dr. Sultana. Thank you.
Thank you, Shira.
Our next lecture is from someone who is a living proof that the distance between you, who you are, and who you want to be is the action you take instead of the circumstances you were put in. While you listen to her, you will realize that she is the kind of a woman who said yes way before she had said how, figured out, and it paid off. The Tamga Imtiaz of 2020, PA's Gold Medal, Research Productivity Award, and several are the proof of her unrelenting endeavors. Please help me welcome Chief Scientific Officer in PCSIR Laboratories, Dr. Shahnaz Parveen.
Thank you very much for your kind introduction. Assalamu alaikum, ladies and gentlemen. This is Dr. Shahnaz Parveen. I am Director General in PCSIR Laboratories Complex, Karachi. And PCSIR is the largest R&D organization in Pakistan. Its units are situated all over the country. I belong to the Pharmaceutical Research Center of PCSIR in Karachi. The women, all the heads of pharmaceutical research centers since 2002, they all are ladies, and I was one of them. I am. There are 6 units in Karachi, and out of 6, 4 the head of 4 units are ladies. These are the units of PCSIR which are situated all over the country. Karachi Labs Complex, where I belong to, Lahore Labs Complex, the head of these 2 centers is also lady. Peshawar Labs Complex, Quetta Labs, we have a National Physical Standard Lab, NPSL in Islamabad. We have Environmental Lab in Islamabad. We have our head office in Islamabad. We have Fuel Research Center. The head is also lady in Karachi. We have Leather Research Center in Karachi. We have Park Suites and Pre-Session Training Center, which are situated in Karachi, Quetta, Lahore, Peshawar, and Gwadar. We have Institute of Industrial and Electronics Engineering, IEEE in Karachi. The head is also a lady, and this institute, it is a degree awarding institute, and it is affiliated with NAD. We have a Scientific Information Center. It is also head by a lady. We have food training center in Iskardu, Salcode Labs in Daska, and Cast Metal and Foundry Technology Center in Daska. These are the units of PCSIR which is present, situated all over the country, and I belong to the PCSIR Karachi. This center has 7 units, and those units, out of 7, the 4 units are also head by women. Today I will share my research work during my PhD and during my job career in PCSIR. Basically, I am an organic chemist, and did PhD from HEJ Research Institute of Chemistry under the supervision of Professor Dr. Ataur Rahman. This is a compound that is N-hydrovinblastine. It is a very active, it is an intermediate compound which is used for the synthesis of vinblastine. If you know, the vinblastine is the anti-tumor active compounds, which is a natural product, and it is present in the Catharanthus roseus, which is normally known as the Sadabahar. And all of you know what is the Sadabahar plant. So this I have synthesized N-hydrovinblastine, which is a key intermediate for the synthesis of vinblastine. And vinblastine is also a naturally occurring compound. This N-hydrovinblastine is prepared by the reaction of leucine, and leucine, it is the most abundant natural product found in Catharanthus roseus in Sadabahar plant. And I also did the microbial transformation of natural products such as 7-alpha-hydroxyfuranolides. And this compound is on microbial transformation. It is converted into this is my, it is converted into these two natural products. All of you are physics and I am chemist. Maybe you understand little bit. Okay. This is a synthetic compound that is N4-nitrophenyl and -4-nitrophenyl urea. It is a symmetric 1,3 disubstituted urea. This compound was synthesized by me. A series of different compounds are synthesized by me, and we found that this compound, it is more active as a urease and alpha-chymotrypsin enzyme. Urease and alpha-chymotrypsin are the enzymes. If any enzyme, if it is present in excess in our body or anywhere, then it causes some diseases in our body. If, for example, if urease is present in our body in excess, then it causes the ulceric peptic ulcer to the body. And if it also causes the pancreatic, if pancreatic is present, then it also causes the pancreatic ulcer in our body. That is very dangerous. And this compound is patented in Pakistan and granted in 2009. And this compound can be prepared by the, when we react 4-nitroisophenyl isocyanate with tertiary amines, we get 1,3 disubstituted symmetric urea. And when the same compound 4-nitrophenyl isocyanate react with primary and secondary amines, then we get N-substituted N-alkyl urea, unsymmetric 1,3 disubstituted urea. This compound is patented in Pakistan. And this I have also got this patent of this compound in United States. It was granted in 2010, and it is also in process in USA, and it was filed in USA in 2007. Another patent, I have got another patent in USA that was the process for the preparation of quinoline-based ionic fluoride salts and immunosuppressive compounds. Those are the one, this compound that is the quinoline-based ionic fluoride salts. It is prepared by the reaction of thionyl reaction by alkylation, and we get the by the reaction of quinoline with by the alkylation of quinoline, we get quinoline-based ionic fluoride salts, and these salts are used for the as a catalyst in Killick reaction and in Killick chemistry, and it is also used for the synthesis of a number of pyrozoles. Those are the more active antibacterial, anti-inflammatory, anti-cancer compounds. These are the standards which I have synthesized during my PCCIR. And these standards are used for the detection of AOZ, AMOZ, and malachite green and leucomalachite green for the detection of these metabolites, or these are the metabolites of nitrofuran antibiotic. And for the export of shrimps, fishes, those products should be free from these metabolites. And if these metabolites are present in shrimps and fish, then the export of those products will be prohibited. I have two international patents, those are granted, and I have also two international patents which are in process. I have 9 international patents in my credit. Now, the most important patent which I have got in Pakistan, it is a composition of standardized ink for stamp pads and method of making same. All of you know that in 2013, when when Pakistan is using magnetized ink, and what happened in 2013 election, that the election was challenged, and Imran Khan also challenged that election, that because the fingerprints of the ballot paper, it was not readable, and we can't find that what happened to the, and we can't count and not rectify the problem what happened, and the opposition at that time Imran Khan was the opposition, and he challenged that election. So what happened on 11th, and another election, local body election was scheduled on 7th December 2013. It should be happen, and we have prepared the magnetized stamp pads by magnetizing, but it was rejected by the Election Commission of Pakistan, and he gave he sent a letter to PCSIR on 11th November 2013, and said that we have to prepare the standardized ink to replace the magnetized ink. That I was in PCSIR at that time. I was only a section in charge in my division in Pharmaceutical Research Center, and that task was given to me. And I have prepared standardized ink in 11th hour, and it was ready on research was ready, and it was completed on 23rd 2013. And then a committee made for the evaluation of that ink. They came, they are from the Election Commission of Pakistan, from NADRA, from Ministry, from Election Commission of Sindh, and from our organization head and chairman. They all seated together and to evaluate that the pads which was made by me by the standardized ink. And it is very hopeful that all the 6 criteria which are required for the evolution of ridges of the thumb impression, it was passed by that it will dry in 5 seconds, and all the ridges can be readable. And they send the thumb impression to the NADRA, those are seated in Islamabad, and they verify, and then that ink was accepted by Election Commission of Pakistan, by PCSIR, by Ministry, and by NADRA. And then we have prepared a new lot of stamp pads on 11th hour. We work up to 2 o'clock in the night, and then we prepared the same standardized ink for the election, which was scheduled to be held on 7th December 2013, and we supplied those stamp pads on 11th hour, and that election was scheduled at the same time. This is the big achievement which I did and my organization PCSIR did. Another project that I did, I was the PD project director of this project, that is the establishment of patent advisory cell in PCSIR Laboratories Complex, Karachi. And this project was funded by Ministry of Science and Technology. And then again, I was selected to run this project as a PD. Through this project, through this project, we have filed 234 national patents all over the country and 15 international patents. And these are the different, these are the patents which are filed to different, not from PCSIR to different countries. And we have filed about These are Karachi Lab 95 and Lahore. These are the units of PCSIR. All together, 151 patents are filed by PCSIR and others. And these are the foreign patents which we have filed during in this project, about 15. Maybe all of you know what is patent. Patent is an intellectual property rights which we get for your invention or innovation. It should have some novelty. It should be useful. It can be commercialized. And I have organized five seminars throughout the country, three in Karachi and one in Islamabad and one in Lahore. I have about 358 national and international publication. Out of that, 324 are in impact factor journals, 34 are in national. And all of you know my impact factor journals, impact factor, it is of 538, H index is 32, and chapters in books, it is 2. I have only, because of due to the policy of HSC that the employees of PCSIR can't enroll students under their, therefore I have only 5 students which I have supervised. I have got past gold medal award in 2022. I have received Tamga Imtiaz in 2022. I have the research RP. I have got the RPS since 2001 to 2017, and I am the only scientist from Pakistan, PCSIR, that he is received RPA continuously. And in the list of productive scientists of Pakistan, I have got top position in PCSIR. I have also awarded that scholarship in 2006 and 2010-11 and had got first position in 2006. I have also get awarded by PSF, that Active Scientists and Technologists of Pakistan. And I have got Star Laureate Award in 2004 and Merit Scholarship. I was also a lecturer in PF College Intermediate before joining PCSIR, where I have also received this award. Thank you so much.
Any questions from audience? Thank you very much, Dr. Shahnaz Parveen. Our next speaker of the session is someone whose project has won the Nobel Prize for the discovery of first radio pulsar in 1967. While I was researching her background, I was absolutely impressed by the amount of work she puts in and her unbounded ambition. She not only has published more than 70 research papers, but also has approximately 50 years of experience of lecturership and visiting professor. She currently serves as a chancellor of the University of Dundee, visiting professor in the University of Oxford, and professional fellow at the Mansfield College. Ladies and gentlemen, our speaker is the epitomization of the phrase, "The world is great, but my ambition is greater." Please help us in welcoming Dr. Jocelyn Bell-Bonu.
Thank you. Am I heard as a first?
Yes, we can hear you, Miss.
Excellent.
Yes, we
Thank
can
you.
hear you.
Right. And share screen. Oh, can you see the first thing of my PowerPoint?
Yes, we can see that.
Right. I've lost it, which is interesting. What is going on? Or something very big. Right. Excellent. Thank you for your help setting up, and thank you for the invitation to be part of this meeting. My talk is in the area of astronomy, and I'm telling what happened when I was a PhD student in the University of Cambridge in the field of radio astronomy. I'm going to say a little bit about my background because that's important to the story. I'll say a little bit about being in Cambridge and the discovery of pulsars. And if I have time, I will say a bit about what we now understand the pulsars are. So I'm British. I started life in the north of Ireland. And I started by failing my first important exam. In defense, there was a higher pass mark for the girls than for the boys. This exam determined whether you had an academic schooling thereafter or a more technical training thereafter. And there was a higher pass mark for girls because at age 11 or 12 in Britain, girls are more mature than boys, and too many girls were passing this exam. Everybody knew that girls were only going to get married, be stay-at-home wives and mothers. It was the boys who would go to work and would be the economic workforce. But if too many girls passed this exam, not enough boys could get good jobs after school. So there was a higher pass mark for girls. It continued till 1983, when finally it was declared illegal that that kind of discrimination was not legal. I was allowed into the academic stream because it was agreed that in a few years' time, 2 years' time, I would go away to a boarding school elsewhere. So they allowed me into the academic stream. And I remember this with great delight because for the first time you had different teachers, not just one. You worked in different classrooms, not just one. And there were lots of new subjects. But I also remember the Wednesday of the first week of the first term in that secondary school. A message went round the first year class, my class, that that afternoon, the boys were to go to such and such a place and the girls somewhere else. And I thought, this is sport. That's why they're separating us. But it wasn't sport. They sent boys to the science laboratory and the girls to the cookery room. No discussion, no choice. That was the way it was. And my parents had promised me I would get to do science when I got into this secondary school. So I tried protesting to the cookery teacher, but she wasn't hearing about it. When I got home from school that evening, I told my parents, and they were furious. The local doctor also had a daughter in my class, and he wanted his daughter to do science, so he was furious. And so were a third set of parents. And all of them telephoned the head teacher. And the next time the science class met, there were 3 girls, us 3 girls, and all the boys. And I don't think the teacher had ever taught girls before. Clearly we were like dynamite. He made us sit right up against his desk, right at the front, so that we couldn't cause trouble. We did physics that first term, and I loved it, and I came top of the exam. I don't remember the teacher praising me. I do remember the teacher being very angry with the boys for allowing a girl to beat them. We did chemistry the next term. That was okay. We did what they called biology in the 3rd term. Here is a flower. Draw this flower, label the parts and learn the names. Right, you finished that one. Here is another flower, a different flower. Draw this flower, label the parts and learn the names. And that went on the whole term. And I thought, boring. And I have avoided doing biology ever since. At age 13, I went away to boarding school in the north of England. It was quite a transition, but I really liked it once I settled in. And I continued good at physics and at maths. I was good at many subjects, but those were my best. And for school leaving, I did maths and further maths and physics. As I went through secondary school, I was thinking, clearly I'm good at physics. I will probably do a physics degree at university. That opens so many doors, but what kind of physicist am I going to be? My father brought home an astronomy book from the public library, and I read that and was thrilled by it and could see all the physics in it and thought, right, I'll be an astronomer. In particular, I want to be a radio astronomer, one of the newest branches of astronomy, studying the universe through the radio waves emitted by the stars and galaxies. So I went to university in Glasgow to do a physics degree. In the 2 honours years, I ended up the only female in a class of 50. And it was the tradition that at that time, whenever a woman entered the lecture halls, all the guys whistled, stamped, banged their desks, catcalled, made as much noise as they possibly could. The female students used to gather outside the lecture room and enter as a group, so that although there was that dreadful barrage of noise, you were part of a group. But as the only female, I had to enter on my own. I learnt not to blush. If you blush, they simply make more noise. And I discovered I could control my blushing. I've lost the technique now, but I know it can be done. I completed my 4-year degree there and then set about finding a PhD place. My first choice was Jodrell Bank, which was famous, but they didn't reply. And somebody told me they wouldn't take a woman. So I thought, not replying is their way of not taking a woman. I didn't think I would get into Cambridge, so I was thinking I would go to Australia, to Sydney, Australia. But the academic year in Australia doesn't start till about February or March. And I had some months in hand, and I put an application into Cambridge just in case. And very much to my surprise, got a place. So, reminder of the geography of the UK. I started life at number 1, started my schooling there. Most of my schooling was in York at number 2. I was a student in Glasgow at number 3. And then I find myself way, way south in the country, close to the capital, London, position 4. You can also see that numbers 1, 2, and 3 are in the rather more mountainous areas of Britain. People down south near London regard up there as uncouth. So I was an uncouth savage appearing in this very civilized place called Cambridge. I realize with hindsight that I was suffering from what we now call imposter syndrome when I got to Cambridge. Cambridge seemed full of young men. There were very few women, young men who knew they were extremely clever and were absolutely sure of their right to be in Cambridge. And here is me, a female from the heathen part of the country, an interloper. And I didn't think I was that clever. And I thought they'd made a mistake, admitting me. I thought they would discover their mistake in due course and throw me out. We now recognize this syndrome. I work in Oxford University now, another prestigious place. And we know to look out for students who at the beginning of their university career are overawed by the brilliance of everybody and get scared and feel they're not bright enough and run away back home. We now have a name for this. It's called imposter syndrome. But we didn't recognize it and we didn't name it back then. And although the risk is that the person feeling imposter syndrome will run away home, I decided I would stay and work my very hardest so that when they threw me out, I would not have a guilty conscience. I was not going to run away. So I'm working in radio astronomy, which is at the left-hand end of this particular spectrum. And I'm actually working at quite low radio frequencies, around about here, this kind of frequency. So radio astronomy started following the Second World War. People who had worked in radar acquired some of the radar equipment, particularly the receiving equipment, and set it up and turned it to the sky to see if they could pick up signals from anything out in space. It was already known that the sun could be a radio source because it was discovered that during World War II, activity on the sun could sometimes interfere with radar, could jam the radar signals. And in fact, when they turned their purloined radar dishes to the sky, they found there were a lot of quite strong objects up in the sky giving radio signals. They were quite strong, and they turned to their optical astronomer colleagues and asked them, what is there at that position in the sky? And the optical astronomers would say, well, there's something that looks a bit like a star, but it's not a kind of star that we've ever seen before. So they became known as quasi-stellar. And the radio sources were quasi-stellar radio sources, or quasars for short. And when I started, there were only about 20 of these objects known. And my particular job was to find more. Within the first week, all the new radio astronomy graduates, well, not all, not the theoreticians, but the rest of us were each given a set of tools. This is my set of tools. And they're not delicate electronics tools, they're heavy duty wire working tools, because that's what I was going to be doing. I was helping build a very large radio telescope. Here am I, covered up because of the cold. This is February in England, and this is our technician, Don Rolfe. And I've been putting connectors on low-loss cables, which you cannot coil up. And here we are checking the impedance, checking that the connectors connect. So there's a slotted waveguide here. Working in the field was always difficult. You were a long way from the laboratory. And for instance, using a soldering iron was difficult because it cooled in the wind. This is the finished radio telescope. It looks homemade. It is homemade. It covered 1.8 hectares. That's 57 tennis courts, if that helps you visualize. 2,000 antennae. There's over 1,000 wooden posts. They're important because they keep all the wires up high out of the wet grass. The grass is cut here, but the grass could grow up to about this height. And wet grass is an electrical short. So you have to keep your bare wire antennae out of the wet grass. And although I'd used transistors as part of my undergraduate project, the radio astronomers were still using vacuum tubes or valves. The project was to find some more of these quasi-stellar, very compact radio sources. Because they are compact, As the radio signal passes through the space between sun and the planets, solar wind, it gets diffracted, and at a radio telescope here, you pick up a signal like this. Most radio sources are sufficiently extended that you don't get this rapid twinkling, you get some sort of average. So you have to observe with a short time constant, under a second. And if you observe with a short time constant, the signal to noise is bad. To get the signal up again, you need a big area of telescope. So I was to identify quasars by their rapid twinkling, scintillation. Having got the telescope built and working, I was the first user. I used it for 6 months and I found about 180 more quasars. So the number went up from 20 to 200, and that was a good number. At that time, the University of Cambridge had one computer. It was as comparable to your laptop. Very few people could have time on it. We didn't. My data came out on rolls and rolls of paper, 30 meters of this every day. And in the 6 months that I used the telescope, over 5 kilometers of paper chart. And I scrutinized it very, very carefully. I quickly identified the quasars that I was meant to be observing. There's also inevitably interference. This is low-level interference. Sometimes it could be like that. But in amongst this 5 kilometers of paper, there was occasionally a signal I couldn't classify. It didn't look the same as a twinkling quasar. It doesn't look the same as interference. But it always came from the same bit of sky when it was there. It wasn't always there when you looked at that bit of sky. It wasn't always showing. But when it was there, it was from the same place. I reckon that this signal occupied about 1 part in 10 to the 5 of chart paper. But because of imposter syndrome and my being very, very thorough, I noticed it. My supervisor rightly remarked that it occupied about 5 millimeters on the chart, and we couldn't see what was going on. We really needed it expanded. And with chart paper technology, expansion is easy. You run the paper faster under the pen, and the pen trace gets spread out. And after about a month of failing, I finally got it. And this is the first trace of the first detected pulsar. The name was added later. My supervisor, Tony Hewish, added that. That's his writing. Incidentally, my supervisor, Tony Hewish, died earlier this week at the age of 97. He had a long life and a good life. So these pulses come regularly. There's a few missing, but here they are again faintly. And they're spaced by about 1 1/3 seconds. These are 1 second time marks. And we had no clue what this was. Radio astronomers had never seen anything like this. Astronomers in general didn't believe anything like this could exist. So our first problem was to get other people able to see it. And we managed that. So it wasn't a fault with my telescope. But it could have been interference. We finally decided it wasn't because this thing kept sidereal time. The stars come around every 23 hours, 56 minutes. And this did also. It kept its place amongst the stars. But because the pulses are sharp, steep, it must be small. But because the pulse period is regular, it must have big reserves of energy, so it must be big. So it's small and it's big. Quite a problem. So we eliminated radio interference. We also eliminated some curious faults with my equipment. You know, Jocelyn's wired the telescope up wrong, said my supervisor. Well, it turned out that a separate telescope with its own receiver could also pick up these curious pulses. So it wasn't that I'd wired the telescope up wrong. But the thing had to be short, had to be small and big, and that kept us really very puzzled. A colleague managed to get a dispersion measurement. He took two of my receivers, tuned one up in frequency a bit and one down in frequency a bit. And after many, many false attempts, managed to pick up the signal in both receivers. And it came first in the high frequency and a little bit later in the lower frequency. And this is due to what we call dispersion. As the radio wave comes to Earth from this object, it passes through space, which is not totally empty. There, excuse me, there are some electrons that will cause dispersion. And he made a guess at the number of electrons in intergalactic space, interstellar space, and came up with a distance of 200 light years, which puts it way beyond the solar system, the sun and the planets, but well within our own galaxy. Now, Tony was much troubled by this idea that they might be little green men, alien civilization signaling to us. And he argued that if it was an alien signal, alien civilization, they probably lived on a planet that went round their sun. And as their planet went round their sun, there'd be some Doppler shift on the pulses. So Jocelyn, please keep measuring the pulse period of this object. Well, we found a Doppler shift, but it was due to the motion of the Earth round the sun. And we could find no other Doppler shift than that. And then, thank goodness, I found a second one in a different part of the sky, and then a third one in a third position, and a fourth one in yet another position. So we don't just have one. And there aren't going to be 4 lots of little green men, all signaling to planet Earth, using the same rather curious technique at the same time. This has to be some sort of new natural phenomenon. The name pulsar was coined by the science correspondent of the Daily Telegraph, one of the major British newspapers, fairly conservative one. His name was Anthony Michaelis. And he said, what are we going to call these things? And we said, we've thought about that, because we had thought carefully whether to describe them as pulsating radio sources or pulsed radio sources, and lighted on pulsating, because pulsed might imply some agency, little green men producing the pulses. So we said to him, yes, pulsating radio sources. And he said, no, you want a short name. What about pulsar? A bit like quasar, which we already had. And pulsars they have become. I'll take just a couple of minutes to tell you a little bit more about them, and then I will stop talking. So we now believe that they are very, very small stars, small as stars goes, only about 10 kilometers radius. They're the remains of a star that did a massive explosion at the end of its life. And in the explosion, the core got kicked against and collapsed down to a very massive state. Because although this thing is only 10 kilometers across, it has the mass of the sun, mass of a typical star, in this 10-kilometer ball. It's spinning about a vertical axis, and it has a very strong magnetic field that's inclined for some reason. And out from the polar regions of this star, there comes a beam of radio waves. And that's what these 2 yellow cones are. And if the cone shines in your face, you see a pulse. If it doesn't, you miss it. And so we probably do not see the vast majority of pulsars because they do not happen to shine in our face. We believe these stars are formed late in the life of a star. They're so very small and very dense, they're probably largely made of neutrons. They're the mass of the sun in a tiny ball, so they've strong gravitational fields. They've also got strong electric and magnetic fields, and they're rapidly spinning. And we believe that when an ordinary massive star reaches the end of its life and explodes, this was the core of the star, and in the explosion, it gets compressed. And the main way to observe these things seems to be as radio pulsars. Some are seen in X-rays, some are seen in gamma rays. We're getting up to about 3,000 known now, only 20 in the visible, 100 in X-rays, 200 in gamma rays. And we think there's probably about 100,000 in the galaxy, and presumably the same number in other galaxies as well. And when a star ends its life, like this particular tiny star marked with an arrow with a giant explosion called a supernova, the core of that giant star gets compressed and makes one of these objects. And we now know that there is one in the middle of a very famous nebula called the Crab Nebula. It was seen by the ancient Chinese to explode about 1,000 years ago. And we had long puzzled how this remnant kept shining. It ought to have dimmed and faded. But we now know there's a pulsar in the middle, and that's what keeps it shining. Thank you for the opportunity to be with you and talk to you. And I hope I've managed to communicate to you a little bit about pulsars. Thank you very much.
Thank you, Dr. Jocelyn, for inspiring a generation of women and researchers.
Thank you so much.
Thank you.
And thank you, Dr. Jocelyn, for your time and be with us. And I appreciate as a conference chair your contribution. We change your time a lot. I know we change your date of speech, and every time you are accommodating and very helpful for us. And with my secretary, Dr. Hira, sitting beside me, she always appreciate your contribution, your efforts, and your understanding of our situation due to COVID. We are highly constrained with the timings. And for your input here, your contribution to the science, I really appreciate for this women session. We coined this idea of women physical sciences because we need to emphasize the contribution of women. From my childhood, I am impressed from the contribution of Madame Curie. Whenever we have an X-ray, we appreciate that she sacrificed her life for us. And in testing this during World War I and other. So you are in the line of the same, and we appreciate all these women who are sacrificing for the science. Thank you very much. Do you have any word?
Hello, Dr. Jocelyn. I'm Hirash Faklodi, the conference secretary, who had been nagging you again and again and again. Thank you very much for gracing us with your presence, for your time, and for accommodating for all my requests. Thank you very much. And I am really impressed, and I kind of appreciate all the efforts that women such as you have gone through to make it easier for us to acquire science knowledge. By just listening to what you had to go through since your childhood, I am just thinking that we now do not have to go through such, what should I say, such kind of gender biasing. Thank you very much. Thank you. It's very kind of you, and it's an honor to be able to talk to you.
Thank you. Thank you. Thank you.
Thank you, Dr. Jocelyn Bell-Burnell. Now moving forward, I cordially request I want to invite Mr. Irfan Ahmed, our conference chair and chairman of Department of Physics, to please come to stage and present Mementa Intervenia, to Engineer Noman Sajjad. Engineer Noman Sajjad, please come to stage and receive your token of appreciation. And I also want Mr. Charuk, member of Electromate, to assist them. He is the sponsor of Amreli, one of the sponsors of Amreli. Thank you, Mr. Noman Sajjad. Now I cordially request Ma'am Aziz Fatma to come forward and present certificate of appreciation to our special guest. Please, Ma'am Aziz Fatma, come forward. I'd like to invite Mr. Irfan Ahmed, to assist her for certificate distribution. Dr. Samar Yusuf, I humbly request to please come forward and receive your certificate. Dr. Shahnaz Parveen, please come forward and receive your certificate. Yeah. Since Professor Dr. Nurul Nahar and Dr. Jocelyn Bell Bernal are not physically present with us, so e-certificates will be given to them after the conference.
Ladies and gentlemen, there is a namaz break. Shuttles are waiting outside the fountain area that will take you to the masjid. The lunch will be served at 1:45 in the Senate Hall. The closing session of the conference will start at 2:30 after the lunch and prayer break. All students and volunteers are requested to remain seated for some announcements. Thank you.
Thank you. All the students, please be seated for the announcement.
Hello. Hello.
Hello. Syed.
Assalamu alaikum and a very good afternoon. I'm Dr. Sundar Sali, Assistant Professor, Department of Telecommunications Engineering, Kennedy University of Engineering and Technology.
And I am Zara Hashmi, lecturer from Department of Physics, Kennedy University of Engineering and Technology. We are going to host the closing ceremony of conference ICAPE 2021.
Firstly, I would request Dr. Irfan Ahmed, Conference Chair, to please come upon stage and receive the honorable guests. I would like to first invite our guest speaker, Mr. Hafiz Muhammad Zubair Arif, to please come up on stage and take his seat. Now I will request our Honorable Pro Vice Chancellor, Kennedy University, Professor Dr. Mohammad Tufail, to please come up on stage and take his seat. I will also request Dean Information Sciences and Humanities, Kennedy University, Professor Dr. Noman Ahmed, to please come up on stage and take his seat. It is time that I tell the distinguished audience about a great person and our guest speaker, Mr. Hafiz Muhammad Zubair Arif. We are highly thankful to your presence with us on this occasion, and Mr. Hafiz Muhammad Zubair Arif joined Pakistan Nuclear Regulatory Authority in September 2003 as scientific officer and was among the pioneer of regulatory review services in PNRA. One of his major achievements was developing an independent regulators level 1 PSA model for Chashma nuclear power plants in 2016. He is currently working as Director Regional Nuclear Safety Directorate of PNRA, and during his 17 years of service at Pakistan Nuclear Regulatory Authority, he performed various reviews and assessments of licenses submission regarding probabilistic safety analysis and internal and external hazard assessment reports of Chashma as well as Karachi nuclear power plants. I kindly request Mr. Hafiz Muhammad Zubair to please come up on stage and share his views about ICAPE 2021.
Bismillahirrahmanirrahim. Honorable Pro Vice Chancellor, Kennedy University, and Dr. Noman Sahab, and also the PESTIC Group Head Plants and Projects, Amreli Steel, and organizers, distinguished guests, respectable faculty members, dear students and participants of this first international conference on applied physics and engineering. Assalamu alaikum to all of you. It is indeed a great pleasure for me to address this forum on a closing ceremony. If I go back almost 5 months before, we had a meeting with physics department of Kennedy University, and we think that how we can start this particular event and from where we can start. And at that time, we actually uh, start from this Chinese proverb that a journey of the 1,000 miles begins with a single step, which and this proverb teaches us that even the longest and most difficult ventures have a starting point, something which begins with one first step. I have quoted it because when in the month of March or April, the Department of Applied Physics shared this idea of having an international conference with us, we were very optimistic. But honestly speaking, we did not realize that the event would have become such a mega event. All praise belongs to Almighty Allah, who enabled them to do this task in such an efficient manner. This mega event is a mega success, I would say. My heartiest congratulations to the top management of NED University, and particularly to the chairman and the team of the Department of Applied Physics. You will remember this success in many years to come. The arrangement of parallel sessions, conducting hybrid mode, management of poster sessions, and many more activities demand huge involvement and care. The department has managed to complete all tasks in a timely and excellent manner. Nobody will believe that this is the first event of a very young and newly established department. I hope that the department will continue with these sort of efforts, and this event would become a regular feature for this Karachi city. Ladies and gentlemen, the conference should not end with this closing session. I would suggest that after a break for a week or so, all the team should sit and write down what they have learned from this conference, just like an informal or formal conference report. This will serve as a historic document for future generations. And secondly, we should try to engage the experts who presented their work and ideas during the conference for future endeavor. Would some international speakers be able to conduct an online workshop for us on some special topics like artificial intelligence, how the students and faculty members can interact with these experts? The Director General NCP has rightly pointed out a discouraging pattern of involvement of physicists in national activities. And he also offered some attractive learning opportunities. We should grasp this moment, as no science or any other learning or discovery can be done in isolation. So we have to establish links between our industry and academia. In the end, on behalf of Pakistan Nuclear Regulatory Authority, I would like to express my gratitude to the conference organizers for inviting our chairman as the chief guest and allowed us to become a part of this event. I hope that our partnership and close association will improve in days to come. With these remarks, I would like to say you Allah Hafiz to all people who are present here and listening to me online. I wish all of you best for your future. Thank you. Allah Hafiz.
Thank you, Mr. Hafiz Mohammed Zubair, for your valuable thoughts. If your action inspires others to dream more, learn more, and do more, and become more, then you are a good leader. Leaders are like our Honorable Pro Vice Chancellor, NED University, Professor Dr. Mohammed Tufail, with his vision, unshakable determination, persistent hard work, pleasant and amicable personality that has led NED University to great heights. With his belief and strong leadership qualities, he gave a new dimension to this university. Being the role model of student community, he is always a great source of inspiration for students to strive for greatness, live to their fullest potential, and always see the best in themselves. Professor Dr. Mohammed Tufail did his PhD in mechanical engineering from Nottingham University, United Kingdom. His services, both as an academic and as administrator, span over 22 years, exhibiting new measures whenever required to impart high quality education and research excellence. I feel great honor and privilege to call upon stage Pro Vice Chancellor Professor Dr. Mohammed Tufail so that he can share his views on this conference.
Bismillahirrahmanirrahim. Thank you very much, Dr. Sundar, for your kind words and introduction. Hafiz Zubair Saab, Dr. Nauman Saab, Dean, Information Sciences and Humanities, Dr. Irfan, Chairman, Physics Department, distinguished guests, faculty members, students, Assalamu alaikum and very good afternoon. Indeed, as been mentioned by Hafiz Saab earlier, that it was a successful event, despite of the fact that we were going through this difficult time of pandemic, and we were rather worried if we would be able to have the people coming in, whether online or physical. Well, alhamdulillah, by the grace of Almighty and with the efforts of all the team, organizing team, and most important of all, the assistance and the support that we received from Pakistan Nuclear Regulatory Authority, PAMSET, and other partners, we had been able to organize this event in a successful manner. As been mentioned that this is the first conference of physics. And yesterday, while we were having this inauguration ceremony, I was just thinking that despite the fact that NED University has reached to its 100 years of existence, but since the beginning, we had our focus towards core engineering disciplines. Started with one program of civil engineering, and then later on increased up to 19 engineering disciplines. We felt that we should come out of the engineering domain and do explore non-engineering areas as well, so as we would contribute by having produced quality graduates in other disciplines as well. In that perspective, I was just thinking that engineering without physics is not complete. And I suppose physics and mathematics are the areas which could be called as the mother of engineering. There are several engineering disciplines which are interconnected, but in a minor manner. But physics is something which is a requirement of all the engineering. So we cannot separate physics from engineering. And that's why this particular program was launched at Energy University. But the good thing is that the things did not remain stagnant. You could see that hardly it was few years back, I would say around 2014 or so, we did start this program of physics, applied physics. And here we go. In the shortest span of time, we had this international conference organized. And moreover, we had very high learned speakers, not from within country, but from abroad. And this hybrid mode has helped us a lot to arrange this particular conference. So I'm happy to share my thoughts, and I would like to personally congratulate all the team, the organizing team, starting from Dr. Noman and Dr. Irfan and all the people who had worked day and night for making this conference a success. I think Hafiz Saab has very rightly mentioned, rather shared some of the suggestions. Dr. Irfan may consider those very important, valuable suggestions. Usually what happens is, no doubt, we do get good papers presented, but at the end of the day, it would be just like Nishistan, Guftan, Brakhastan. So I think this is a good idea that we have to have a follow-up, because that particular follow-up would help to arrange the subsequent conferences in this domain. Second thing is, of course, this was a first conference. And Dr. Irfan, I recall yesterday in his speech, वो कहते हैं ना जमानत पहले उन्होंने ले ली थी कि कोई गलती हो, कोई कमी पेशी हो, तो आप उसको जो इग्नोर करें प्लीज. तो I would say the same thing, that is the first conference, and I'm sure there would be a lot of room for improvement. And I see that the team is geared up. We are having a support from very renowned institutions like Penra and PAMSET, and we've got a partner university being Syed University. So hopefully we would further improve, and I'm very much grateful to all the sponsors, starting from Amreli, Steel and the rest. They've been wonderful partners. They helped us, and without their support, we would not have had this successful conference. Dr. Irfan, maybe next time while we have a second conference, despite of the fact that we had covered many domains in this particular conference, and there was one particular event about the women in this domain. I think that was an excellent idea. Whosoever had it, it was an excellent idea. Maybe it is yours, Dr. Good. It was a good idea. So next time you may think about assigning some theme of the conference, and the focus would be a particular theme. That would help us a lot, and we would be able to catch more people under that particular domain. Lastly, we should explore the possibility of getting these high-valued research papers published in reputed journals. That would also help the authors to get due advantage of what has been presented in this conference. So with these remarks, I would like to again thank you all, and I hope that all of you had benefited from this conference, especially the students had the flavor of what the kind of research taking place in this discipline of physics. And I'm grateful to all the participants who came out of Karachi, from different parts of the country. I'm again grateful to our sponsors, as without their support, we would not have had this conference held successfully. Thank you very much, and God bless you all. Assalamu alaikum.
Thank you, sir. Now I will request Dr. Irfan Ahmed, Conference Chair and Head of the Department of Physics at Kennedy University, to please, if he can share his closing remarks with us.
Assalamu alaikum, sir. I take the privilege of speaking in Urdu because ये program का part नहीं है. परमिशन उन्होंने मुझे अचानक बुला लिया। तो सर की इजाज़त से इज़्ज़त माब जनाब प्रोफेसर डॉक्टर मुतफैल साहब, इज़्ज़त माब जनाब डायरेक्टर PNRA हाफिज़ सईद साहब, नुमान अहमद साहब, टीन नवाज, आप सब लोगों का बहुत बहुत शुक्रिया। बहुत सरपरस्ती रही, सबकी काविशें, अल्लाह ताला हम सबको इसमें कामयाब करे। हमने पहले ही माफ़ी मांगी हुई थी, सर ने सही कहा, तो हमें पता था कि हम गलतियाँ करेंगे, तो उम्मीद है आपने माफ़ भी कर दिया होगा। तफसील से शुक्रिया आपका सेक्रेटरी कॉन्फ्रेंस अदा करेंगी। सर ने जो विमेन एंड फिजिकल साइंस की बात की, तो मुझे मौका मिल गया माइक का, तो मैं सर को बताऊं कि हुआ ये था असल में कि एंगरो का एक फंक्शन हुआ था यहाँ पे। तो उन्होंने कहा इफ़ यू अडॉप्ट ए थीम ऑफ वुमेन दे विल सपोर्ट यू। तो मैंने कहा वाकई हम इतने मुतासर हैं, वुमेन ने इतना काम किया, लाइक मैडम क्यूरी ने अपनी जान दे दी एक्सरे मशीन जो आज हम मज़े से इस्तेमाल करते हैं, उन्हें भी नहीं पता था कि एक्सरे क्या है। तो इन्वॉल्व होना चाहिए। तो मैंने टाइटल सोचा था विमेन एंड फिजिक्स। तो डॉक्टर इमरान कहने लगे कि टेलीकॉम वाले के फिजिक्स में तुम्हें इतने मिलेंगे नहीं लोग, तो मेक इट विमेन एंड फिजिकल साइंस। तो पूरा नाम जो है वो इस तरह डेवलप हो गया। तो मैं उन्हें भी शुक्रिया करना चाहता हूँ कि उन्होंने उसको इम्प्रूव कराया। बट इन्वॉल्विंग वुमेन इन साइंस, हमने सिर्फ इनऑर्गेनिक ऑर्गेनिक अलग किया हुआ है। अगर हालात बेहतर हुए तो थीम को पूरा जेनरिक कर देंगे वुमेन इन साइंस इंशाल्लाह ताला। बाकी सर आप तमाम लोगों का बहुत बहुत शुक्रिया। इंतहाई अदब के साथ हमारी कोई कोताही से माफ़ करें। थैंक यू वेरी मच।
Thank you so much, Dr. Irfan Ahmed. Now it is a time to call the person without whom this conference could not be possible. The person who gave his tremendous efforts to make this conference successful. She is an excellent example of a great leader and a co-worker. Her calm personality is a challenging situations is an inspiring factor for us. The person I am talking about, none other than our conference secretary and assistant professor, Department of Physics, Ms. Hira Ashfaq Lodi. Please welcome Dr. Hira Ashfaq Lodi to vote of thanks with huge round of applause.
Bismillahirrahmanirrahim. Honorable Pro Vice Chancellor Dr. Mohammad Tufail, esteemed Dean Dr. Numan Ahmad, and respected Hafiz Muhammad Zubair Sahab, my fellow colleagues and dear participants, Assalamu alaikum. As the conference is approaching towards the end, I would like to first of all thank Allah for making this event successful and making it possible for us to organize this. Alhamdulillah. There has been a tremendous amount of support and guidance from our mentors, Dr. Sarosh Hashmat Lodi, Dr. Mohammad Tufail, Dr. Numan Ahmad, and Dean Electronics and Telecommunications at Syed University of Engineering and Technology, Dr. Muhammad Amir. We are really grateful to all of you for your kind support. Any conference would not have been possible without financial and scientific contributions. We are extremely thankful to all the presenters for their contributions from around the world towards making this conference possible, especially international keynote speakers and invited guests. They were very enthusiastic and they contributed very positively despite of different time zones. Any conference would obviously not be possible without the financial support. So we had support from many different sectors. The financial support of Umbrelli Steels was huge, and we are really thankful to them, especially Mr. Numan Sajjad, Mr. Uwais, and the marketing team of Umbrelli. DNAP Corporation, we are very thankful to you. Abdul Majid Sahab from Abdul Majid International, we extend our thanks. Thank you very much for being a kind support. K&N Enterprises,
Rastec Technologies, Electrical Engineering Services, Watson, the Equipment Company, Instrument Technology, and their representatives who joined to make this event. Our deepest gratitude to Pakistan Nuclear Regulatory Authority. I didn't mention you guys within the sponsors because you have been much more than sponsors merely. You have extended scientific support, you organized a pre-conference workshop and whatnot. We are thankful to Sir Syed University for extending help and very graciously accepting few of the conference papers for their recognized HEC recognized Y category journal. We are very thankful to the Sir Syed University. Thank you very much. Lastly, I am extremely thankful to the various departments which made it possible, especially IT and the Services Department of NED University of Engineering and Technology. Thank you very much. You have been with us day in and day out. You have been very kind, just catering all of our requests, delaying your prayers, even having delayed lunch. Thank you very much. And a very huge thanks to all the students and the volunteers who put in their hard work and efforts to make the event successful. Thank you to the organizing committee. As I'm saying that on the behalf of the department, I shouldn't be saying that, but it's from my side. Thank you very much, the organizing committee. Thank you. I'm really thankful to you all. Thank you. Thank you, Dr. Hira. Now we are moving towards the award distribution ceremony. May I request our guest, Mr. Hafiz Mohammed Zubair, and Pro Vice Chancellor, Professor Dr. Mohammed Tufail, and Dean Information Sciences and Humanities, Professor Dr. Numan Ahmed, to please come forward. And I will also request Dr. Irfan Ahmed, Conference Chair, to please assist them in the award distribution ceremony. I request Pro Vice Chancellor, NED University of Engineering and Technology, to please present memento and souvenir to Mr. Hafiz Mohammed Zubair. I request Pro Vice Chancellor, NED University, to please present memento and souvenir to Dr. Mariam, who is representing Department of Electronics at Syed University of Engineering and Technology. I request Mr. Nabil from Electromate Society to please come on stage and assist with the distribution of souvenirs. I would request the Pro Vice Chancellor to please present a memento and souvenir to Mishkat Sahab, sorry. The conference chair, Dr. Irfan Ahmed, is requested to please receive a memento and souvenir from the Pro Vice Chancellor on behalf of Dr. Saqib Anjum from Department of Mathematics. Yes.
Now I will request our guest, Mr. Hafiz Mohammad Zubair, to please present memento and souvenir to the conference organizers. And the first person I would like to call upon stage is Dr. Hira Ashfaq Lodi. Please come on stage and receive your memento and souvenir. I will request Mr. Tahir Jamal to please come on stage and receive the memento and souvenir. Dr. Iqbal Tariq is requested to please come upon stage and receive his memento and souvenir. Dr. Sabah Javed is requested to please come upon stage and receive her memento and souvenir. I will request Dr. Ruhi Zafar to please come up on stage and take her memento and souvenir. I will request Mr. Junaid Kareem Khan to please come up on stage and take his souvenir and memento. Mr. Ghulam Mustafa, can you please come up on stage and receive your memento and souvenir? Dr. Saida Nadir Ali is requested to please come up on stage and take her souvenir and memento. Dr. Uzair Majid is requested to please come up on stage and receive his memento and souvenir. Miss Aisha Khurshid is requested to please come up on stage and receive her memento and souvenir. Mr. Hafiz Muhammad Usama Ayub is requested to please come up on stage to receive his memento and souvenir. Ms. Zahra Hashmi is requested to please come forward and receive her memento and souvenir. Ms. Sana Beg is requested to please come on stage and receive her memento and souvenir. Ms. Momina Tariq, can you please come on stage and receive your certificate? Ms. Mehwish Javed is requested to please come up on stage and receive her certificate. Okay. Ms. Afsha Ahmad is requested to please come up on stage to receive her certificate. Mr. Muhammad Abir Chukhtai is requested to please come up on stage and receive his certificate. Ms. Haya is requested to please come up on stage to receive her certificate. Ms. Zahra Hashmi is requested to receive the certificate on behalf of Ms. Mehwish Javed. I will request our distinguished guest. Sorry, Miss Haya, please can you? I request our distinguished guest, Mr. Hafiz Mohammad Zubair, to please take his seat. Now we'll be presenting certificates to the hosts of the conference. Ms. Zahra Ashmi is requested to please come forward and receive her certificate. Rumesa Sadek is requested to please come up on stage to receive her certificate. Mohammad Faik Khan is requested to please come up on stage to receive his certificate. Rabia Batul is requested to please come up on stage and receive her certificate. Mohammad Shahrukh is requested to please come up on stage and receive his certificate. Hamna Sheikh is requested to please come up on stage to receive her certificate. Mohammad Zishan is requested to please come up on stage to receive his certificate. Dr. Sundus Ali, thank you very much for graciously hosting the event. Please come forward to receive your certificate and souvenir. Thank you once again, Dr. Sundus. Okay, on that note, we are now moving towards certificate distribution among the head of the teams of the students. And there are a few members of the team who are heading different departments. So first of all, I'd like to call upon stage Dua Kamran to please come up on stage and receive her certificate. Mohammad Sohail Qureshi is requested to please come up on stage and receive his certificate. Is he here? No. Can Mr. Adnan please come on stage and receive his certificate? Okay. Mohammad Charukh, can you please come up on stage and receive your certificate? Mr. Nabil Ahmed is requested to please come up on stage to receive his certificate. Syed Hamza Sharik is requested to please come forward and receive his certificate. Hasnain Murad is requested to please come up on stage to receive a certificate. Mohammad Faik Khan is requested to please come up on stage to receive his certificate. Muhammad Hassan is requested to please come up on stage and receive his certificate. I will be announcing the three winners of the poster session. Second runner-up goes to Muhammad Adnan. Muhammad Adam, sorry, Muhammad Adam. Can you please come up on stage and receive your prize? First runner-up goes to Hafiz Tehmoor Ahmed. And the winner of the poster session is Arif Akhtar Azam. Thank you, Mr. Hafiz Mohammad Zubair Saab and Pro Vice Chancellor, Professor Dr. Mohammad Tufail Saab and Dean, Professor Dr. Noman Ahmed and Dr. Irfan. This is the end of the award distribution ceremony and also the conclusion of the closing ceremony. And I'm very thankful to all of you for being here and being a part of this event. All the best for the future. Allah Hafiz. And can I call upon the faculty on stage for a group photo, please? Allah Hafiz.